So let me first welcome Professor Barbara, which is here. And let me also welcome the 4 alumni that will make the presentation this morning. Okay, so we have a slight change in the order. So Sofia will start, then we have Sherkan, Sahad, and Harohi at the end. Then we go down around 11, and we have a social activity inside the building. Weather is not, the optimum. So as we informed you yesterday, we cancel, unfortunately, the soccer game. But we will stay together in the room downstairs. At the end, we will ask you for the posters, also to be ready with your posters, because it's exactly the same room we are going to use in the afternoon for the poster session. Then we have lunch. We restart at 2 p.m. with a talk from Grace Lewis, which is here as well. And then we have this project exhibition and demo in the room downstairs. And then we have Barbara with the talk in the afternoon, and then the dinner, okay? So let's start. Thank you for being here on time. And let me ask Sofia to come to the stage. Where is she? She was here a second ago. Disappeared. Okay, we will wait for her to come back.
Okay, a great pleasure to present for you today in the morning after everybody energized after the coffee. So I decided to split my presentation into 2 parts. So I will talk first about my thesis, and the second part would be about the company where I work and some of my experience there in Valachai. Hello. Perfect. So 2 parts, the thesis and then my company slides. Okay, so I did my thesis in the University of Balearic Islands about medical images, and the topic is radiomic features in hepatocellular carcinoma, stability with regards to lesion segmentation. A bit complex topic, I know, but I will explain you what was it about in simpler words. Today I'll give you some introduction, background of the study, problem statement methodology, some results, and then some discussion on the topic. I did that a bit squeezed version of my thesis presentation. So if you want to know more details about this, reach me out after the presentation. There is this type of cancer called hepatocellular carcinoma, which is a very common form of liver cancer. And what we were trying to do is to use radiomic features to predict whether the patient will get better after the treatment or not. It's a very, very common issue that the segmentations that are done on the CT scans of the organs are different, because it's usually done manually, and different people do the segmentations of the liver and the tumor in a bit different precision. And for that, it's pretty hard to extract the radiomics and have a unified model that can predict the survivability of the patient. So what we were trying to achieve with this study is to understand how differences in the segmentation masks of the liver and the tumor impact the stability of the radiomic features. Because the more stable are the radiomic features, the easier it is to get for us well-working model. So it's easier to train the model that will be able to predict. Something is back. Yeah, so the objectives were to to investigate the stability of the radiomic features, then check the impact of the transformation of different segmentation masks on how the performance of the model changes, and then how sensitive different features are to those changes in the segmentation masks. So the process, how the research was done, is first we had the images of the CT scans, so the data set. Then I have created multiple transformations of the segmentation masks. So in the end, I got few data sets because each of those data sets have a different transformation. Then I was extracting the features. We were extracting the radiomic features using those segmentation masks that were transformed. Then, using the radiomics that were extracted, the random forest model was trained for each of the transformation, and then I have conducted the feature analysis. So the data set, you can see the example. So you have the segmentations of the liver and the tumor. So in that data set, I had 105 patients. And some of them had large tumors, like those green parts of the images are the tumors, and red is the liver. And some of the patients were like having small tumors as well. And those were DICOM images, and those who are studying in Spain will definitely know how to work with this kind of images, which is a bit more complex than I expected, because CT scan images are very different than PNG images that we are used to work in computer vision field. Then I have done the transformations of the mask. So you can see, for example, the dilation means that I enlarged the mask that was originally in the data set. Then translation means that I moved a bit each of the masks to the side. So now my segmentation masks are not fully 100% correct when you overlay it over the CT scan. Some more transformations that were done: rotation, shearing, eroding. Then about the model that was used. So we, in the beginning of the process, we went for pretty simple but very powerful model. It was random forest. Why? Because it's easy to use random forest with high dimensional data. It's pretty robust. It's easy to interpret the results, which was a very important point in our case, because we were trying to understand which features impact the results of the model. So with random forest, you have very transparent understanding on which features were used, so it's easy to interpret the results. And about the results. So I will talk about the model performance. So I used the radiomic features, did some feature cleaning, and then the feature that we were trying to predict is whether the patient will improve after the treatment or the opposite. So it was either 1 or -1 for random forest to decide. Then another part of the results would be feature importance. So which features were more important when the model was making the decision, and we will try to find the connection between all of these different models that we train for each type of the transformation and understand which features are dominating, are the most important for each of the trained model. Because that way, then in the future, we can build a unified model which will work well and not depend on the segmentation transformation that much. And then the feature stability. So whether the feature was changing a lot when we were making the transformation or not. So the model performance, I have trained one random forest for each type of the transformation using the radiomic features, and here you can see the results. And the interesting part that the original data set, so without any transformation of the segmentation mask, is not always performing the best. So if you check the test F1 score in here, you can see that the dilated model was performing better in that metric than the original one, which was pretty interesting to discover, and then we were trying to dig a bit more deeper around this. Then I have this per sample model performance. So I have 105 patients. I have predicted the results, so I ran the inference using the trained model. And here we are trying to understand how much the model performance changes per sample. And as I mentioned, there was a class -1, so the patient will get worse, or class 1, that the patient will get better. And what we can see in this graph, that F1 score for the validation data set degrades less for the class -1, meaning that for the model it was easier to predict that the patient will get worse than for if the patient would be getting better. Then I also have this graph for per transformation model performance, which shows us how well model performs on the validation dataset for each transformation. And we can see that the dilated model that goes first over here on the slide performs pretty well. So for some reason that in the beginning we didn't really understand, so when you enlarge the segmentation mask of the tumor, for the model it's easier to predict whether the patients will get better or get worse. And then we have the rotation, the shearing and translation, which performs with average accuracy, so nothing too significant. And then going forward with the feature importance analysis, so how we were trying to understand which features are less important, which features are more important. So we used two approaches for that. So there is a permutation feature importance approach, and then mean decrease in impurity, which also allows you to understand the feature importance. I will not dive deep into the differences between these two methods. Then, considering that we had so many models and so many data sets, for the feature importance we were trying to focus more on the dilated model because it was showing better results than the original at some point, and it was performing very well, so we wanted to dig deeper into that. And also for the translated mask and the model that was trained, it was performing pretty well, pretty average, and that was something interesting to see because it's a pretty common error for human to make when they do the segmentation is to not align perfectly with the edges. So the translated was also a second choice. Looking at the graphs for feature important analysis, we can see the top 20 most important features in the original model over here, and we can see that the shape dominates in here. So the maximum 2D diameter row is the most important feature which is used for the random forest model to understand, to predict whether the patient gets better or gets worse. And then if you take a look at the feature stability, again, we are focusing on the dilation and translation. So we were trying to compare the percentage in feature values between the original and transformed masks and use overlap metrics like intersection over union and thus dice score to quantify the mask differences. And here, instead of focusing on the different features, because there are hundreds, to find the intersection between those features, I was focusing on the categories of the features. So the features that are showing, talking about the shape, the features like first order features like skewness and entropy, and then texture-based features as well. If you take a look at the feature stability when we compare the original and dilated masks, we can see that there is a pretty big instability in the graphs. So it kind of makes sense, because when we dilate the mask and we compare that to the original, of course, the random forest after being trained does not rely on the shape as much as it would rely in the original mask. And then for the translation, we can see that there is almost no, those features are very stable, because when we only transform the mask, but don't change, only translate the mask, so move around, but don't change the shape itself, then the features remain very stable in that sense when we're talking about the shape. Okay, and then a few words about the key findings. So first of all, for the model degradation, we understood that aggressive transformations significantly affect the class 1. So if the mask is not very well defined for the tumor, it is very hard for the model to predict whether the patients will get worse, because it will assume that the patient will get worse by default. Then for the feature importance, the transformation causes a shift from shape-based features. So in the original model, it was mostly relying on the shape, but when you make different transformation to the mask, then the texture and intensity-based features are more reliant to make any conclusions on the patient's outcome. And then for the feature stability, so shape features are unstable under dilation, but stable under translation. And also, while the texture and intensity features show moderate to extreme variability. So it wasn't very conclusive on those type of features. Study limitations. So there was only one data set used for this research, which means that we cannot generalize and make the same conclusions if we test that in a different data set. Then random forest was used to train as a main model. So deep learning approaches were not explored, since the explainability of those models is way more complex and it's harder to get. So that is something to discover in the future. And then limited transformation, so only dilation and translations were analyzed in depths. So maybe for the rotation or erosion for different kinds of transformations, we could see more conclusive results. Any questions about this topic? Did you get any idea or understanding what did we do in my thesis? Like a bit? Glad to hear that. Also, as you may have seen in our schedule, I work for a company called Valohai, which develops MLOps platform, and I work there as a customer engineer. Huh? Oh, sorry.
No, it's very interesting. So I had a student doing a master. So find a data set which is annotated without the subjectivity of different, let's say, annotators. Mm-hmm. So did you control for it? Were you able to control for it or not? So the different annotation style.
Yeah, that's a very good question, and that's also one of the limitations of the study, because only one dataset, which is publicly available, was used, and the style of the segmentation is the same in that dataset. But I must say, so maybe some of you will be interested, there is a great collaboration with the University of Balearic Islands, with the local hospital and radiology department, and they did gather their own dataset of CT scans with this same cancer type. And the next step in the research would be to use that dataset, which is very special and nobody can really use it because it's owned by the university, to make a similar research. But in my case, I didn't have big issues in that sense because only one data set was used.
Thank you for your presentation. I would like to ask, what's your opinion? I mean, this approach that you have for the radiomics feature could be exported to other type of scans like PETs, X-rays, MRIs. I mean, what are the problematic? I mean, in that sense.
Do you mean the differences in extraction radiomic features from different kind of?
Yeah, I mean, could you export your pipeline to other kind of medical examinations?
It's pretty hard to answer because we were a bit limited in time and didn't do that much discovery around the existing papers. In this case, these were CT scans, and it was quite a hassle already to work with this kind of images because it is pretty challenging because this is DICOM files, and it took quite a lot of work to extract the features from the DICOM files. Yes. And I didn't test it with any kind of different image types.
Yeah, but it would be interesting to export it, to generalize it to other type of gliomas, for example, instead of only the hepatic.
Instead of?
Other type of glioma or cancers, instead of only the hepatic.
Yeah, with the cancer type, again, this dataset was used because there was a possibility to expand this study to a locally created dataset in a Spanish university, so that's why we chose this type of cancer.
Thanks.
Okay, no more question.
Great. So now I want to switch the vibe from scientific to a bit more entertaining. And I want to present you a bit on what my company does and what I do in the company, and a bit of my path towards that position. How much time do I have left? Like 10 minutes? Is okay? Maximum. Great. Okay, so here are my slides. I want to tell you about what Valohai is, why companies need MLOps, and what do I do there in Valohai. So, 60-second version of what Valohai does. It is a MLOps platform which allows you to manage your data, training, and deployments all in a single pipeline, seamless deployment and the process of the training. Then we usually work with AI native companies, so we try to look for those who have AI as a core business, and then we try to collaborate with them to improve their flow and how they work with ML. Why do they choose us? We provide the orchestration, versioning, lineage as a given, and we just take the heavy work of the ML engineers when they need to work around the orchestration and managing their data on their own. Valohai allows the engineers focus on model development, and the rest is managed by the platform. So you get faster time to market. So for businesses, it gets so much easier to release new versions of the models, and they are not locked in any cloud platform or in any tool, because Valohai is very agnostic and it's easy to start with and easy to stop using. And we have these cool companies like Boston Scientific, Safran, and we also have lots of clients who work with medical images like OnKI, Floy, and then the others. So what companies want? They want to have this linear growth. They assume, so the more people they hire, the more productive it gets, but it is not always true. Often it happens like this because you have the code base is growing, you have more challenges to onboard people because the tooling is complex and it's hard for them to get started. So yeah, you need to maintain everything you develop. Difficult to collaborate because different tools are used. Hard to onboard it, as I said, and growing code base. So with Valohai, we want you to have not just linear growth, but exponential. So you can reuse the pipelines, models, data, and discover everything in one single plane. Where does the gap come from? So usually people they have their data in the databases, they have blob storage, they use EC2 instances, SSH to the machines, they use MLflow to track their data. Other team can use weights and biases or spin up another MLflow, or then they decide to build Kubernetes because you can manage your resources more efficiently. And then if you want to build the pipelines, you would do something like Airflow in your architecture for ML. What happens? A lot of glue code. Lineage is complex. You cannot find out where does this model come from, what data was used to train this model, and 50% of the time goes to maintenance. Valohai is different. Quickly, 4 rules, why, and what do we do differently. So have you ever had issues with third-party API when you don't understand what's happening? So with Valohai, we try to avoid being a black box, so everything is very transparent. And Valohai's rule number 1 is never trust a computer. So everything that is happening, you are in a full control, and Valohai decides nothing. When you want to reproduce different experiments, but you cannot because the README file is outdated, so people are having different challenges with packages, etc. So Valohai ensures that any experiment you run within the platform can be reproduced in any moment, doesn't matter if it was 5 years ago. So Valohai's rule number 2, never trust a human. So Valohai automatically versions everything and allows you to reproduce your experiments. Then issues in production. So something might go wrong. Valohai tries to ensure that your debugging process is very simple. Everything should be a pipeline. You have full lineage, full logs on everything that is happening. It's so easy for you to pinpoint where the problem is. And Valohai's rule number 3, that everything breaks, we will help you to debug more efficiently. And then, are you a full stack, all stack Pokemon? Often people get hired to be a ML engineer, but then they have to manage their data, manage the compute, work with firewall rules, figure out the data, key roles assumed, Docker images, a lot of the things, but you just want to focus on the model. So we believe that everybody hates ops. Valohai doesn't, I do a bit. So we just want people to let them write their code and we will manage the rest. So this was the explanation where does the productivity gap comes from and what Valohai tries to fix for the companies that we collaborate with. This is how Valohai works. So you work on your own machine. You can use our CLI tool to launch an experiment. It goes to app.valohai. Valohai adds the job to the queue. And now everything you see on the right part of the screen is we managing your cloud resources. So it goes to the queue, it scales up the machine for you, make sure to use your object storage. You can use web app to run your experiments, and if you want to automate the whole process, you would use REST API. And this works seamlessly with all the other clouds that are out there. So Azure, GCP, and we can also orchestrate your on-premise resources as well. And from the engineer's point of view, you just change the queue that you want to send the job to, and you don't write any glue code to connect to your S3, spin up the machine, nothing like that. And then, me flying to Valohai. How it started, I did my bachelor in computer science, lots of studies. Then I got to R&D incubator, and I was working with virtual reality glasses, very big milestone in my life. So fun stuff over there. Then did exchange in Sweden, met some people, was amazing. Then I started working as a computer vision engineer. We did super cool stuff with this kind of mesh removal and object removal. Very proud of that period of my time. But I got bored, and then I was like, do I even like what I do? And I wanted to do something else. And then Ediss came to my life. Yay! Then I had to get my summer internship. I randomly reached out to Valohai on LinkedIn asking, is there anything maybe I can be useful? I got a summer internship with them. After the summer, they were like, do you want to stay? And I'm like, but I'm going to Mallorca. I want to have fun and not work in Mallorca. But I had to stay because it was something very magical happening, because how I got to the company and the people that I've met there, and I saw myself there in the future. So I decided to stay. I became customer engineer. These people in my company try to help our current clients and potential clients to understand how the platform works and onboard them to the platform so the teams are able to start working with the platform, and the whole process of their experience with Valohai. We are there for them, was ready to answer any questions. But we created a new team in Valohai, which called pre-sale team. And 2 weeks ago, I became part of that team. So now I will focus more on talking to potential clients and showing them the platform, allowing them to test the platform in their environment, doing the installations. So that is these roles in Valohai that I've been doing. require technical knowledge and understanding what ML is and how that works, especially also the DevOps part included. But also you get the joy to talk to people and to try to manage their expectations and try to sell them the platform. It wasn't always easy, but Doris says that you should just keep swimming, and I'm sure that all of you in the end will be doing great. Just never give up and just keep swimming. That's it.
Eddie.
I am working hard to get you an opportunity in Valohai to have a summer internship, but nothing official yet.
Any questions or comments?
Great.
Yes, one.
First of all, thank you for the presentation. Both were really nice. You mentioned you randomly reached out to Valohai. Like, what do you mean randomly? Did you just drop an email, or did you apply to a position, or how did it happen?
Great question. Practicalities. No, it was very inspiring and unexpected because I wanted to reach out to Valohai. I looked through LinkedIn and checked the people who work there, and I noticed that one of the guys I'm connected on LinkedIn, but I didn't remember. And apparently, when I was working as computer vision engineer 2 years back, he reached out to my company saying, "Do you want MLOps platform?" And I had the thread with him talking about we don't need MLOps platform. And I didn't know that Turku existed. I didn't know what Finland is. No, I did. But very interesting. And I just texted him saying, "Oh, maybe you need something." I sent him my CV and motivation letter. And 2 weeks later, he reached out to me. We went for a coffee to Cafe Art. And that's how I became part of Valohai.
Okay, thank you very much.
And Valohai is actually an associate partner of Ediss. Valohai helped us to do the first winter school in Lapland.
Okay. We want to know that if you have any thesis position in your company for the second year students.
Can you repeat, please?
Do you have thesis position for the second year students? Not internship.
No, unfortunately, thesis is not an option in Valohai because we don't really do any ML inside. So we provide the tooling for ML. And even myself working with Valohai, I did my thesis with the university. I was using Valohai platform to do my experiments, but Valohai itself doesn't do any like research or scientific stuff or ML.
No more questions? Okay.
Perfect.
Thanks. Thank you,
very
Sofia.
much. I wish you all the best, great winter school, and for those who are finishing Ediss this year, the best of luck with the thesis. It's gonna be okay.
One. Okay. So, let's start. My name is Shirhan Azimov. I am from Kazakhstan, where I finished my bachelor's degree in. Okay. I can continue. Where I finished my bachelor's degree at Nazarbayev University and graduated in 2022. And then after I started my master's degree in Noble Academia as a part of Ediss program. And after the first year, I did my internship at Nokia, and then the second year was here in dell'Aquila. And then I'm working right now at Unix, which is like a northern part of Italy, close to Venice. And my thesis was paraphrasing user stories with large language models. We basically evaluated how good 10 open source LLMs are in paraphrasing. And during my thesis, I executed more than 150,000 prompts. Yeah. So, despite of the LLMs and this part, I'm interested in blockchain, which is non-popular opinion here, I think. But still, I am active open source contributor to the blockchain projects. One of them, for example, as a Nifty Inc., is a total visits 143,000. And for example, here you can see the image which was drawn one of the artists several years ago. And it's like an NFT. So not just an image, but also the drawing. So you can see the process of the drawing, how artists drew everything there. And interestingly, even though it was drawn several years ago, it was one of the people bought it for $150. I don't know why, but okay. So there's something happening, but glad to be working on this as well. But okay, let's now talk about the companies that I'm working on, Unix. First, I will talk about the company, what we do there, what is the product portfolio, and then we will briefly talk about the computer science, what are the teams related to IT at Unix, and then we will talk digital ID, which is the latest development of ovens from our company. So, the taste of building success. In Unix, we create state-of-the-art ovens and experience services inspired by inventive simplification and driven by pursuit of perfection. So you're probably thinking ovens, but yeah, later I will explain what are the features for these ovens. So, success is proven by numbers. The Unix was founded in 1990. So, it's also an Italian company, and here you can see the major technologies, important business decisions that were made throughout the time. I will not go through all of them. I will just briefly mention one of this, and then we will focus mostly on about digital ID, which was released in 2021. The turnover is in 2023 was 290 million euros, and as you can see in the graph, in the last 5 years, we are actively hiring. Unix is around the world. So right now we have 42 branches. And also we have local partners around, I would say around the world. So I would assume that it's covering all of the, not all of them, maybe most of the countries that were sitting here. So I assume. And the total number of people is around 1,300 right now, where 40 of them live and work outside of Italy. Yeah. So our customers. There are very big companies, you can see, IKEA, Sheraton, BMW, who else? Coop, McDonald's, and other very big companies from around the world. So that's why we have a lot of different branches around the world. So, and also important things that I would like to mention, that vertical integrated process. What does it mean? It means that we design and develop manufacture everything in Italy, in Padova, Veneto region. So it means that we create the electronics and stuff, manufacture, assembly. So we also keep the quality very high and good. Yeah, and I also visited all of these fabrics, and it was very interesting to see how they are creating detergent bottles and fueling them, everything. I mean, there are 100 or I don't know, a lot of bottles, and everything is managed by 2 people, but in fact, everything is optimized. So, Unix, we are creating the ovens, but it's not home ovens. It's for the professional at restaurants or bakeries. Let's see. Here you can see like the first two is a chef top. The first one, chef top digital ID, which I will talk about today, and chef top mind maps. So the difference is about the software that we have. And the chef top is about for the restaurants and gastronomy, so it will allow you to cook, grill, steam, and like other processes that that chefs are needed. And for the baker top, as you can understand from the name, it's for the bakery and pastries. The next one is Speed Pro. So you can see for the Speed Pro, you don't have the window glass. Sorry, you don't have the glass. So the idea is to cook very fastly, in just 1 minute, maybe something like this. A Velio is like a hot refrigerator. So it helps to cook. It helps to keep the temperature of your food warm throughout for a long time. And let's talk about the computer science at UNOX. There are a lot of teams related to information technology, but I would like to mention only two of them here. Digital experience team where I work, we design, develop web and mobile application, corporate websites, cloud and IoT infrastructure for ovens and ovens operating systems. Also, infrastructure and cybersecurity team who manages and supports for corporate network and hardware and software. Also, research and development, we have software development team. They are responsible for algorithms for cooking and cleaning processes, and low-level software for electronics. Also, they are developing of user interfaces, and I guess the most interesting might be for you is automation and AI team. They are responsible for the machine vision systems, and we're gonna see one of the development, which is about related to food recognition and robotics automation. So let's go to the most interesting part. Digital ID is the project that I am working on right now. Here we have two ovens. One of them was released in 2015, Mind Maps, and the second one, Digital ID 2022. Do you have any ideas what other programming languages were used in this? Any assumption, any guess? Yeah, probably for the embedded devices, IoT devices, it's difficult to guess. So on the left part, you can see Mind Maps. It was developed with C, completely with C. And for the right one, it has a React. So I think probably most of you already heard or know. So literally how it's possible to have React. So it's literally a website running, and you can easily develop with the React framework. Yeah. So first architecture. In 2015, it was a first architecture where the company learned a lot. The connected ovens were 300, and the data logs were only 5 gigabytes. We also had our own premise monolith, which means that everything was managed in our company, by our company, and we just had one web app for service operations. Right now, we have more than 60,000 connected ovens, 10 terabytes of data logs, and we are already not managing ourselves. We are using AWS for the servers, high availability and fault tolerance. Also, we have already more mobile apps, web apps, and other things. Yeah, here's the graph how it's growing from 2016, and it's surpassed already 60,000 connected ovens. So, digital ID in the oven. Let me show them videos that the marketing team did. Okay, there is no audio, I guess. But in the middle, you can see the dashboard, which you can customize and deliver, basically as a desktop, the most important features that you need. On the right side, you can see the cooking editor, where you can select the time, the temperature, the steam, ventilation, which you prefer to cook. And also for the food, you can select the thickness, internal temperature for the food. And on the first one, you can see several timers running, which means that you can cook at the same time several food. And every food, every tray will have own timer. Also, I think the most cool part is clean. For the restaurant, it's very important to clean the oven often. And oven is, thankfully to the sensors that are inside, it can also track how clean it is oven, and also it can clean itself, so it helps a lot. Yeah, and let me show. So as you saw, you can control your oven just from your phone. UI synchronization with servers and cloud infrastructure. So cross-platform synchronization that keeps the status and oven continuously up to date across all of the devices. So basically, you can just control your oven from your phone, which can be useful. For example, you're away and you want to clean your oven. It shows that it's dirty. You can just start the cleaning process or start the cooking. Another feature. Let's say that for the chefs, it can be a new thing, interacting with the oven. So you can book an appointment with our Unix support service team, and they can have a call, video chat about asking how to navigate across and maybe help with the recipes that you have. Customizable UI to load your own recipes, which means actually we are also providing you can cook vegetables salmon and stuff with this recipe, which is already selected at the temperature and stuff. You just need to start the button and that's it. But some chefs prefer might be they prefer to have own recipe, a temperature, cooking time. So it's easily possible to do it from your phone or from the oven. Okay, optic cooking. So maybe it's this one which would be interesting to use. That is related to machine learning. So I hope it's pretty clear. The idea is just for the chef, you're not putting your food and then selecting from the timer what you're cooking. You just put it to the oven and that's it. It already starts the timer by itself. It scans the food that you have, maps the correct timer and starts the timer. So for the chef, it's much easier. Just put the food and go continue working on other foods. Okay, data-driven cooking. On this project my wife is working. So in this website is a management dashboard where you can see the a status of the oven, how clean it is. For example, here you can see also a program manual multi-time, what was a cooking time for the last 7 days, at what time what was cooked. So it's very important for the businesses to evaluate how it was the oven used, and also here is how dirty it is the oven. So and you can easily start cleaning. With a self-clean. Okay, I think this might be the most interesting part. Is a very simplified version of the architecture, so you get an idea how to use AWS tools. In our case, Amazon Poly. I think it's a bit it's in research, but the idea of this is a text-to-speech platform. So you just send it an Unix oven, which is located here. So for the text-to-speech, and then Amazon. So you saw a service talking with a customer service. It's possible with Amazon Chime. Amazon Chime is which helps to have a video chat with the Unix support team and then Unix oven from the Unix oven. Also, we have a digital ID cloud where we have Amazon Cloud Front, which is helpful to transfer the web pages, media, images, videos, and other things with a low latency and high availability. Let me check. Yeah, with a low latency. It's very important for us because we are working around the world, so it's important to have this kind of tools so it will not lag during the video calls or something like this. And also we have Amazon API Gateway, which is where you can deploy and manage your APIs. It acts as an interface between your clients and the backend services, AWS Lambda in our case. So, and AWS Lambda, I think most of you already know that it's for the serverless compute service. You just develop your code, push it, and that's it for the managing, and it will be managed by itself, like for the scaling and this stuff. Also, we have Unix app for like a DDC or data-driven cooking, where it's also like you can see the dashboard and also manage your oven just from here. And then you can see like the database like on the right side, Amazon LDS, relational database, MongoDB on Amazon, and Amazon S3 for the storage and files. Yeah, and quite recently we are changing a bit the architecture. We are moving from AWS Lambda to AC containers to reduce prices. And yeah, the question is, yeah, do they need to write a report like after for the winter school? Okay. So here's the summary, which I hope will make your life easier, especially the last part, which is like a advertisement of my Telegram channel. But yeah, so you can take a picture because I'm not sure if I can share like all of the presentations. So it might be useful for writing a report. Yeah, that's it. Thank you.
Thank you. Do we have any question? Yes.
So you mentioned earlier that you are dealing with 10 terabytes of data, right? Logs data.
So I'm doing, sorry, what?
So you're mentioning that you're dealing with a lot of logs data, like terabytes of logs data, right?
Yeah.
So I wonder if you are using any AWS serving to manage that logs, because I didn't see that.
That's a very good point, actually. I don't know, because it's responsible other team. Usually they are, like we are having lunch and some of them like getting in a mail, something like that there is something with oven. So unfortunately, I don't know like what is the service for it.
All right.
Well, thank you for the question. I will clarify when I come back.
Okay, no worries.
Yes.
Hi. So, like your oven, I also love cooking. For me, cooking is all about the taste. So you might have definitely tasted the food cooked on your oven. So do you get the same taste like it is cooked on gas or anything?
So as I understood, the question is if we are getting the same taste, right, for the same recipes. Yeah, for sure. Like one of the ideas to have, like we have already like a chef Unix recipes that was recommended by chefs from our company how to cook like a potatoes or salmon. So I mean, you will get the same taste since it's the same oven.
Okay. Yeah. Thank you. That's my question.
Thank you.
More question?
Hello. Yes. Okay, so I think we have talked a lot about this, but previously you didn't mention about my question about the maybe like what is the opportunity for working in this company, and like maybe you can explain like what is the minimum requirement for the like let's say like to have the full time in the company.
So as I understood, the question is like if I have a full time, right, and then another. Okay. Sorry, can you repeat?
No, I'm asking about like what is the opportunity right now? Like, is there any opening opportunity for the full-time position? And also like what is like the minimum requirement for the working there?
Okay, I got it. So actually, I mean, yeah, like there are a lot of open positions, feel free to apply. So the question is if you are willing to relocate to Padova, yeah, because we are working with the hardware and it's necessary to test everything on the hardware. That's why it's like important to visit like as a company. So yeah, but there are open positions for sure, like for the AI and automation team who is doing like a food classification as one of their project, and then also there's like a software engineering team who is doing like with low-level programming languages like a C or Rust, and our team who is like managing websites and cloud infrastructure. Thank you. Okay.
Yeah. One more question.
Hello. So I have a question about the functionality where the oven scans the food and it identifies what kind of meal it is, and then it can predict how long it should be cooked, right?
Yeah, so basically, optic cooking is like you put it to the tray, it's already like on top there is already like a scanner which will take a photo of the food and then will select a proper timer for it.
Yeah, and okay, so it knows by the look of the food how long it would take to cook?
Yeah. So just from the image, it's possible to map like what is the timer for it, and
Do you know by any chance how that was trained? Was it a rule-based or was it like neural network that decides these things?
as I know, it's like not that like a complicated. I mean, they don't use GPUs or something like this, so I assume it's like not that like a high level or not so deep neural networks. I think there are neural networks, but not like a LesNet or something like this. I think some simple neural networks.
Yeah, because I imagine there would be a lot of nuances in how long.
Sorry, can you repeat?
I would imagine there will be a lot of nuances and small differences. For example, different types of meat and different types of deer. and animal.
But also, it's possible like to indicate like a sickness of the meat because it's very important. Like if it is like a very sick or thin, and also like it's possible to test like what is the temperature of the meat already from the beginning. So so from this, it's possible to map, and of course, it's learning and getting better.
Yeah, that seems fun. Thank you.
Thank you.
Thanks. One more quick. Yeah. One.
So there must be an ML team. So, does the company do any machine learning?
Yeah, there is a machine learning for example, as I mentioned, for the optic cooking, it's like a computer vision.
Okay.
And also they are doing robotics and automation, but I'm not sure about this part.
But you do software engineering.
I do software engineering. I'm working like completely on the oven, how it looks. So I'm refactoring the pages, and also I am working on the new generation of the ovens, which will come like in 2-3 years, and it will be like on a Rust.
Super.
Thank you.
Sophia, I thought you will ask, do you need a new MLOps platform?
Yeah, I mean, we don't do much MLOps, and it's not that.
No more question?
Sebastian?
Yes.
Okay, so my question relates to also the question from my colleague about the capabilities of recognizing the type of food you put in the oven. So, what do you exactly do? So you put the categories and then you go with that? Or actually the learning algorithm even checks the differences that there may be towards a certain food? For example, there was the example of fries, of a hamburger, and does the algorithm actually check, for example, the thickness of the patty, or I don't know, some differences of it, or it just goes by the category, it just checks the type of food and accepts like a general overview?
Yeah, I would say right now it's the type of the food. Like it maps like what were the foods, and with the from the multi-time like options, like a chef Unix, that we have like many different options, like a potatoes, for example, and it maps, okay, it's potatoes, let me cook it for 20 minutes, something like this.
So I guess this could be also an area of improvement for it, to add some more nuance into the algorithm so that it can check also smaller details into the food.
Yeah, definitely. Yeah. Thank you for the suggestion. The optic cooking was released like just like in the previous year, like in the end, like 2024, like 3-4 months ago, so not that while ago. So it's improving. Yeah.
Okay. Thank you.
Thank you.
Thank you.
Okay. Thank you very much.
Thanks. And now we continue with Sad.
Does it show my present? Will it automatically show my presentation? Do I need to? Does it show? Okay. Can you go? No, does it show now? Something? No, nothing. I think we need to switch there.
Yes, now. Wait, no.
Do I need to do something?
No, you don't need to do anything. You want to go. Wait, no, it's fine. Oh, was it? Do you have a mic like that?
No.
No. Yeah, move it down. I want to move it. This is stay.
Yes.
Completely white.
Yes, yes, yes.
So can you go on presentation mode? No.
I am already in the presentation mode.
Okay.
For example, I'll give it a try.
Yeah, this is what is on the screen. Something is happening.
Ah, yes.
Is it a resolution?
Join the mirror. Better?
Yeah, try that.
Ah, now it's visible. No?
No. Try your phone.
Mirror.
No, the same. I mean, you have to.
Seems really nice. There? Okay.
Try this.
Okay, this.
Try this.
Sure, maybe with an adapter.
Yes, yes.
Here. Yes, it's the bone too. It restart automatically. Let me start my implementation. Usually it works. Usually it works.
No, it's the frequency.
Right? Hmm?
The second display frequency is not good. Look.
The frequency of the...
Yeah,
It's the
yeah,
frequency.
yeah. Can I present from my...
The second display.
Yes.
Yes.
Settings.
Second.
Number 2, click on number 2.
Second. Change this. Try this.
50?
Try.
Yeah.
Change this.
This one?
Go lower. Lower.
14, 40?
No, lower. Lower. This.
No.
This.
Try 90, 20.
Yes.
Yes. Now it's
Now it is the first display. And you change it now.
can I present from my mobile?
Or we switch with Huawei.
Or I
And
can
then-
share
and
the
then
presentation with you.
If
and
you
I
have
use your
a
laptop.
key,
Do you
USB
have a
key
do you
for
have
the
a,
for
yeah,
our
it looks
key.
like, do you have a USB key?
Or maybe I can use Sherfan's laptop. I can share the presentation with Sherfan.
Yeah.
Sherfan,
But maybe we switch with Huawei. And then we do can you move the is it PowerPoint or?
it's on the Google slide. So if you,
Allora mi sa che fanno prima con la chiave.
I'm sharing my slides with you.
Where?
On Gmail or whatever you use on this on this laptop.
Okay.
Tell me your. What's your email?
They will share.
You can type. Should be Gmail. That will be easy.
Is it typing?
Don't check. Don't check. I think it's stuck.
What if I ask Huawei and then you deserve it? No?
Yeah.
Okay, yeah, that's right.
Huawei, can you jump in? You need to accept the access. So
Entire screen. Let's start with entire screen. Or like, okay, but like,
Mirroring, yes.
but can I do Windows or app? Can I do extended display? So
No, not the standard. Mirror.
yeah,
You will get.
yes, window or app. Choose a window or app. Mirror.
Mirror.
yes,
This window. So,
yes, it works.
but first I need to switch to not this, but like I have this thing also like where I need to open that link.
Yes.
So I would be able to do that too. No. So we change
Should just time the.
because like if I mirror the entire screen, then because again I was here about to present into presenter mode, something
Yeah.
like this. So and if I go here, so choose mirror from the menu. So where do I change the settings?
Which settings?
Because before was visible.
Yeah, it was working.
Yeah.
Choose the mirror from the.
Sorry.
Okay.
With this.
Okay. Good. Okay. Allow.
The same. Go
You
top
just change
right.
your
Now.
setting.
Click here. Yes.
Choose content.
Click extended. Maybe it is what you want to do.
Yes.
Yes.
Doesn't show up.
Go and press yes
Okay,
now.
now something.
So go and press
Yeah.
yes. So I think that is your background.
Yes.
And then if you go and present the
Try to start presentation.
Mm-hmm.
Yes.
Yes.
Yeah.
Okay.
And then if you want to, do you want to show the
other
browser?
one? Yes.
Then I think you will need to move it to the extended.
Display.
Yes.
So
It's-
like,
it's-
no. A bit, but
It's the
that's,
Mac.
it's the Mac, but like if I go this, then I can just
Move it. Yes, as soon as
Here,
wait,
but like-
wait a bit. Yes.
Where do I?
Now, okay, you need to exit the presentation. Mode, and then you yes, and then that you move. Now, now, for example, now it will work.
If I
In the second screen. Yes. You need to minimize it.
yes, perfect.
But it might flicker, so don't get like.
Wait, don't worry. I mean, not just that. No, let's do it. No, let's do it. Let's do after. No, otherwise. Okay. So ready? Yes. Okay.
The microphone.
Yes. Okay. Whew. Hello. Attention, please. Okay. Hi, guys. So I am told that this is a Mac thing, that it will keep flickering like this, so we can still continue talking, but today's topic is starting from medical imaging and going to architecture, basically starting from my thesis intern journey and going towards my current role in Nordia as an IT architect. So the journey so far has been getting enrolled at Ediss. That was woohoo. I was very happy. Then during my summer internship, doing research and assistantship at Obo Academy, again under Sepino's supervision. That topic was doing a literature review on challenging medical data sets. But that's not that much relevant, maybe. Then I got enrolled at UNIVAC for my second year as a part of Ediss. Going forward, I started my thesis internship in February with Varian, and then I left that and I started working at Nordia as a graduate, and now we are here at Ediss Winter School, presenting. So, before we start, I really wanted to know what I should focus on while I present to you. You know my journey. Now, maybe it's like you can scan this QR code, and then we can see here. Maybe I can share that again. Yes. So what do you want to know most about, or what should I focus on in today's presentation? And that will wake you up too. Okay, maybe 5 more seconds. Okay, 5, 4, 3, 2, 1, and I lock this. So now it won't change. So we have, okay, mostly Nardia. Okay. But then there is an open question as well, that apart from this, if you need me to focus on something else, then you can just type in some text, and I can try to focus on that. technical questions only. Money. Okay. Wow. And I close this in 5, 4, 3. 2, 1, go. Okay, so no technical questions, only a lot of how to get thesis, what do you do, how to get Nardia, why did it deduct my €3? Okay, I'm going back to the presentation now. And we go back to presenter. Yes. So, my thesis project, let's start with the thesis project. The thesis project was on automatic relabeling of OAR images using auto-segmentation. Quite a mouthful of title, so let's break it down. Let's start with auto-segmentation. Mostly every one of you will know what is auto-segmentation. Personally, I did not, so I started learning it or getting to understand it in layman terms, which mainly is that, for example, you have an image of a cat sitting on a couch. So using AI models and using auto-segmentation method, you can separate that cat from the couch. That is a basic example. And in real life, we have other examples such as when you have your face lock in your cameras and it extracts your face and then unlocks your phone, or photo editing apps. And in medical scenario, you have X-rays and MRIs where doctors, or I would say, doctors would use it to auto-segment or extract particular organs from the images. And this aspect we were using for our thesis project. Then, what are OAR images? OAR stands for organs at risk. As the name suggests, it is the tissue surrounding the affected or the carcinogenic tissue that is at the risk of radiation. So to break it down, you have a target or the cancer-affected organ, you give them radiation, but the organ surrounded that target tissue is called your organ at risk or OAR. Yes, and I just wanted to add that because for 6 months I was looking at this. So this is the auto-segmented or segmented half brain, 2 eyes, and some other organs there. Then let's move to relabeling. Here where the actual problem statement of the thesis lies. Why relabeling? Okay, we all know relabeling, that's basic English, so I'm not explaining that. But why relabeling? Because in some data sets, these patient organs or patient structures have French labels, for example, or very inconsistent labels. A left eye can be named as eye left, eye_L, or some other French name which I do not know. So to enhance collaboration, to have standardization, we need relabeling, and that was the purpose of this thesis project, that we want to automatically relabel these organs at risk or OAR images. Then the high-level workflow. So some of you attended the same presentation at Varian. So from the feedback I got, and also my personal realization, that let's break it down to very simple terms. That is, that we have some original patient structures and original patient files. We have an in-house auto-segmentation tool that I had little contribution, not that much contribution to. That tool takes this organ structures or original organ structures as input and then generates new or generates patient structures. We compare these two original and the generated patient structures using similarity scores. There are a couple of them available in medical field. And then based on how perfectly they fit together, we are identifying the organ. So the entire aim of this process of doing with similarity scores and seeing that how perfectly they are aligned is to identify or classify the organ. And once you have identified the organ, you can just relabel them. Now, relabeling was one of the use cases. With this, we addressed two more use cases, which was filling in of missing structures. This is the scenario in which, in a patient file, some structures are missing. So we thought that since we already have generated patient structures from auto-segmentation, let's use it in another use case of filling in those structures. And finally, we have quality assurance. Then we thought that since we are already comparing using DICE similarity scores, might as well use it for QA, you know. We like QA. So then we came up with a third use case that let's use it for quality assurance. And that was the entire thesis project in a nutshell. What did I learn in these 6 months? I did not know much about radiotherapy, none at all. So I learned what is radiotherapy, how does it work? Why is it that if you give radiation to cancer cells, they die, but the normal cells are completely fine? Apparently they are not. It's just that the normal cells can regrow and the cancer cells cannot regrow. So this was new to me. And how it plays. What are the various medical imaging file formats? It seems that each company are having their own tool and they do not even have one standardized tool to access the different medical imaging file formats. So that was quite a handful again. We have applications of auto-segmentation. We have Dockerization. So that was a concept that I was working while studying in dell'Aquila for one of the projects, for two of the projects. And then it was really nice that I got to use it for my thesis as well. At some point, we were trying to call a Docker image from another Docker image. That did not happen, but yeah, we did a lot of experimentation with Dockerization. And patience. Oh God, it took a lot of patience. Because to process one patient file, it took 7-8 minutes to get the results and see if the DICE scores were mapping correctly or not. So I learned a lot of patience in those 6 months. Okay, let's go ahead. Role as an IT architect. This was also, I think, from the poll, popular. So when I entered into Nordia, I entered into the department called Group Architecture. And in this group architecture, I came across different roles, and I did not know what they were, like what is a business architect? There's someone called an enterprise architect, there's someone called a solution architect, and I had no idea which is which and like, what are you guys doing? So I started to research a bit on it, and also like, I got to know over these 6 months. So a business architect doesn't much care about technology. He knows something, but not too much. His main aim is to get the business going and running. He needs to focus on your strategies, the goals of the company, the weaknesses of the company, and the key processes of the company. So that is your basic business architect. I mean, feel free to read the small text, but I just thought that it would be good to have an overview. Enterprise architect. Now, enterprise architect, in my opinion, and my personal opinion, is the most intelligent person in the organization because he has some background in technology. He knows what the technology is going around. He has focus on the strategy, and he's the perfect balance. And an enterprise architect makes sure that the company's technology is well organized, efficient, and cost-effective. So they clean up and simplify the company's software and then present it to the business people. that, okay, this is what's happening in the company on a software or a technology level. They understand how data and systems work, and then they give potential solutions according to what would be the best, aligning with the business goals and strategies. Then we have a solution architect on another lower level. He is more focused towards technology and doesn't really care that much about the strategies, because the enterprise architect has already laid out a complete strategy map. Another example also that I missed was that enterprise architect designs artifacts like transition and target architecture for a company. So that was one important one. But solution architect designs the technology solutions that is needed to meet a company's end. For example, that you have a simple thing that you need to design a new mobile app for a particular feature. So what backend services would be used by that application is done by the solution architect. Coming up with the requirement that you need a new mobile application, that was done by a business architect. And then just saying that this app is supposed to look like this, it is supposed to have these 3, 4, 5 features, and it should follow, for example, Flutter out of my blue. That is done by enterprise architect. And finally, we have the technical architect. He designs and optimizes the tech setup, or he creates smooth processes within the technology team. He ensures that all things go in a smooth manner, all the DevOps-related operations, and help the teams to develop in a faster and a smarter way. Then I came across architecture governance. I heard about the term before, but then it was again complete new, like why do you need it? But within 1 month in Nordia, I realized that you do need architecture governance. But it's such a heavy term, so I Googled the definition. The definition says, practical and orientation by which it literally translates to set of rules and regulations. Enterprise architecture. Enterprise is anything but large companies which have multiple departments, systems, processes, and ways of working. So, practice and orientation by which enterprise architects and other architectures, so the overall things, the entire architecture department and all the processes, people that work in an organization are managed and controlled. By managed and controlled, that it ensures efficiency, it ensures security and long-term success. Was that me? No, my phone is on silent. That wasn't me. And on an enterprise-wide level, that is the same set of rules and regulations need to be followed through the entire organization. So take the enterprise as, like, for example, building a new city. You need to have some guidelines for the buildings, roads, and infrastructure, and you need to have the same guidelines throughout the city. Otherwise, one person is following one guideline and one rule, and the other person is following a different one. So these need to be followed consistently. Architecture governance characteristics. There are many characteristics, but overall, they focus on these 4 main, which is control and monitoring. You need to set up that how are things controlled in a proper way. This is done using artifacts, so proper artifacts have been set up, that you should follow these and maintain these. Compliance, all these artifacts are designed keeping in mind the compliant rules, regulations, and not even just internal policies, but external policies as well. Then you have effective management. You need to ensure that these templates are periodically reviewed and they are also approved in board meetings. So there are multiple meetings throughout in a week also for continuous approval of these artifacts, which people work on while updating anything. And accountability, that the right people take responsibility for the decisions. So nothing goes through without going through your line manager or your leader. So every document or artifact that you prepare is first approved by your line manager and then the line manager's manager. So architecture governance is maintained and followed. There are various architecture models followed within a company. These are some of the examples. But then I just didn't want to talk about the theory and give examples. So rather I thought that I can give an example of an architecture model that I can actually find and that we use also, which is a business capability map. So let's talk about a business capability map and just focus on one of the models. Now, is it possible? Okay, you can see. Now, again, a very big term. What is a business capability map? It is basically the things a company can do. We can break it down into a simple sentence that all the things a company can do. And why do you need this? A company should already know what it can do. But well, it's very confusing because there are things that you can do and you do not know to what level you can do them. So you need to know on which level you are currently are and which level you need to reach to, so as to say, for your goals and success of a company. A capability map shows all the core functionalities or all the core functions that a company needs to perform. So for example, strategic management, marketing, support, finance, these are always going to be there and consistent among all the companies. And then there are some which are specific to the industry the company is based in. For example, here I have put an example for the finance industry, where you have retail banking, investment banking, loans, mortgages, and so on. Okay, we can go forward. Ways of working. This was another diagram that I came across while studying, and I can say for a fact that this is how the things are going in Nordia. Let's start with the software system. So for the software system is an implementation or is designed using a model. The development team works on the software system. The development team works on the software system, and the software system is built using the model. Now, who works on the model? The model is worked by the software architect. And this model is designed using the meta model that was made by the enterprise architect. The difference between a model and a meta model is a model tells you how to build a software system, whereas a meta model just tells you how to build that model. Now you might think, why do you need that again? Well, it is quite important because in a company as big as Nordia and in a company which is like quite vast, there needs to be rules and guidelines on how you're going to build a software system which is followed in the model, and how are you going to build that model which is followed in the meta model. So to ensure consistency, we have these meta models in place which are designed by respective enterprise architects. So overall learnings in these 6 months have been why governance processes exist within a company, what are those governance processes, what is governance in general, how to create different artifacts and get them approved, what are the different kinds of artifacts that exist in the first place, what is the requirement of having so many artifacts in place, and how to periodically update them so that you are not old. And data engineering concepts, which I did not cover particularly, but that is again a huge set of rules and regulations about how data needs to be stored. So even before the data engineering and data analysis start, the data engineering department within an enterprise plays a huge role with these compliance issues and governance issues. These are references for all the diagrams that I have used, so feel free to go there and if you want to read more over there. And thank you. Now I can even go on answering the questions that were there earlier, or just feel free to pop up all Q&A questions. Sherkan.
Okay. One. Thank you for the presentation, first of all. I have a question since you studied here, how useful was software architecture and model-driven engineering courses in yours? Like, what did they really help in your knowledge?
So if I understood, did software architecture and model-driven courses at UNIVAC helped?
Yeah, did you already know all the stuff when you came to Norway, or did you have to learn much
I
more?
think I had to learn some new stuff. The guidelines are same, so I knew where to look for them. For example, I could relate to the software architecture class in the sense that, yeah, there is a lot of rules and regulations that exist, and there are governance things that you need to take into account. But understanding that why they exist and why is it needed, and appreciating that they exist, that happened when I joined, and when you see that how important they are. Other than that, it just feels more theory, and now it's more how they are implemented. And for model-driven engineering, maybe not so much. Because mostly all the models and artifacts that exist are with industry tools, and they usually use Microsoft PowerPoint, Microsoft Word document, and things like that. So these artifacts are made for ease of use. So, yes.
Okay, thank you.
Thank you.
Hi. How was your experience when you were learning the business processes of the company? Was it hard? Because it's a big company, right? So I'm guessing it's very complicated to understand how the business operates.
Yes, it is. Actually, it is quite difficult to understand the trade-off, because when you're in a big company versus when you're in a small company, it's like, okay, something is not working. There's a lot of technical debt. There is a lot of that we are paying a lot of money because it's a legacy or an old system. But you just can't go there and change the system, because there is a loan that was issued 20 years ago, and which will terminate in 10 more years, and then you cannot decommission that system. So that system still needs to keep working. So the business requirements do not meet the technical requirements. And then that is quite difficult to understand, because from my mindset, it's just decommission it and build a new one. That is the logical choice. Be updated with the new technologies. But it does not happen. And another example of the business requirements is that they see a lot of things, and also with a big organization comes a lot of people, and a lot of people have a lot of different opinions. So there is no right way to go on one solution for one problem. So there is a lot of disagreement, there is a lot of picking up of one solution randomly. So these all things, it makes difficult to understand, coming from because I've worked in a small company also, where you think about something and just you do it, it's finished. Whereas a company where everything goes through a process, or a regulated process. Yes.
Thank you.
Thanks.
More questions?
My question is related to your diagram about the different levels of architects. My question relates to, due to such a big corporation like Nordea, has such 4 layers in this case, what would be the strategies that would take to mitigate, for example, information being lost through each layer? Because in this case, the business architect doesn't have much of a technology focus, while the enterprise and the solution have more. And the information going from layer to layer could be misinterpreted, or maybe even understood completely different. So how would the company, in this case, mitigate, what strategies to take to do that?
Okay, so for different layers, for example, the enterprise architect in my scenario, or what I have seen, is generally the line manager of all the solution architects. So whatever solution architects do, or the work that they present, is presented to the enterprise architect, and enterprise architect also works on some projects of his own. Now, in this method, the manager always defends the work of their, of their employees, so as to say, or of their team members. And this manager then presents it to the business architect. So since there's like one person in middle who will always support the solution architects and who knows that, okay, what work is being done, and then she or he presents it to the business architect. Also, to avoid these loss of information, it's always just as simple as setting up a meeting. So if there are 3 different people, or if there are like 4 different people required to agree on one particular problem, you just put them all in together in one meeting and then you ask. So everybody is going to raise their own issues. Okay, no, this is wrong, this doesn't work for me, no, this doesn't work for me. And then you attain a common consensus.
Okay,
Yes.
it's clear. Thank you.
Yes, so a lot of debating happens in these meetings, a lot of them.
One more question.
Okay, thank you for the presentation. Can you tell us about like a comparison between doing research at Varian and working at Nordia now? Like, how do they compare? Which one do you like? What are the good things?
In terms of working as a research, like difference between working as in like research and corporate, or like work culture of 2 companies, like.
Yeah, I guess between the companies more.
Between the companies, I think both are very big companies. Varian itself was like has multiple or is based in multiple locations. So the similarity was the first thing that comes to my mind is the similarity that getting anything done in both companies was really difficult because it goes through an approval process. It goes through an entire approval process for any little change. And both these companies have very private data or very, regulated data. There's one medical data and one banking data. So again, they were very sensitive regarding their data. The difference, however, was that Varian, the branch in Finland, was comparatively small. So even the company is quite big, the Varian branch in Finland was quite small. So the office atmosphere was more or less relaxed. People knew each other, and you could meet them for coffee, learn more things. Whereas Nordia, like even the Finland office is like so big, it would have like more than 1,000 employees. So it's almost so fast moving. Like if I want to have lunch with somebody, I need to schedule it like 3 or 4 days in advance or the previous week, something like that. So the work cultures differ a lot in that sense. But if you have any other aspect you want to know a difference, then just let me know.
Yeah, thank you. That's good enough.
Okay.
Thank you. And we still have 2 questions in the back.
How was the process of getting to Nordia?
There are 2 application rounds, and I got rejected for the first application round, and then got accepted in the second one. And they give an online assessment test, and then you have an interview with your department manager, and then you have an interview with your, the team manager or in the team that you would be placed. So that was the process, and from what I know, after a little bit of interaction with the talent acquisition people over there, it's mostly like shortlisting of resumes after the online assessment is done. And then they forward the shortlisted resumes to the relevant managers or the relevant departments, and then they see which resume works for them, and they send out interview emails.
Okay, so I want to elaborate more. I want to ask more. So let's say like we didn't have any background, any fundamental about these architecture things. So it's still possible to apply. Like,
Yes.
Will they have the supervisor mentorship or something in the company?
Yes, of course. So I did not have any architecture background as well. So as I mentioned, like it is just the pile of resumes getting shortlisted and then getting forward to different managers and then just getting picked up. Now, I believe that happens quite common, irrespective of whether it's Nordia or not, that there might be something that you're not that experienced at, or it's not in your resume, and yet there is something that catches the eye of the manager hiring, and you get picked up. So within my group of friends, I have heard it once or twice that it has happened.
Oh yeah, because like from previous shared question, like I understand, from what my understanding, like actually you know some of it because like you learn it here in L'Aquila, while
Yes.
I'm not from here.
Yes.
Thank you for the answer.
Thank you. I think now it's time to move. Short one. Go ahead. Yes.
We wanted to confirm if the only roles available are roles for architects, because maybe there are other roles like data science or software engineering.
No, but these regulations are for like all, I would say all profiles, because since it's a big organization, what happens is you need to be compliant with a lot of things because of external regulations, and these external regulations give birth to like internal regulations, and that are imposed through any profile, be it data scientist, be it as small as like, customer engagement. They have a set of rules that they need to follow, and yes. So it is irrespective of that. For example, in data science teams, one common problem that we face, not we, but like what I've heard, is that they are not free to train the data on any model. So even if they have some idea, they cannot train it. I was quite surprised to know that there weren't existing analysis on marketing campaigns in Nordia, for example. Like marketing campaigns are so important and they generate a lot of revenue, and if you just automate them or like have some model prediction for them, it would be quite good. But that does not exist because they weren't or they couldn't use the data earlier.
Thank you.
Thank you.
Thank you, Arwe. So now we move to the last alumni presentation. I am very happy you have many questions for the alumni. I think it's very good.
It's like multimedia.
Yeah, but I will put the power supply. It helps with the... So, what was the charger? Yeah, it used to be short. It's only the charger from the start.
So now it's like double charge.
Yeah.
Next to version. So now it only shows the presenter view or the everything. Just show the slide and keep the presenter view.
Yeah. Try to be close from the microphone. That's Yes.
Hello everyone. Closer. More. Hello everyone. Okay. First of all, I would like to thank the Ediss consortium for inviting us to the 4th Ediss Winter School. So thank you for that. And now I formally begin my presentation. My name is Saad Wasim, and today I will be presenting the topic of mining maritime data for sustainability. It will be a short presentation. It has like total 6 components. I will begin with the introduction and a little bit of my background, Then I dive into the role of data analyst and the data analysis that I was doing, and then how it overlaps with data engineering, and how both of these things lead to data science. So a little about myself. I graduated in 2015 with a bachelor's degree in computer science. Right after that, I joined a German company, Koya Solutions, and I started working mostly for the German clients. Right after that, I continued with a multinational company, Systems Limited, where I spent almost around 4.5 years. The opportunity that attracted me to join Systems Limited was to work for Associated Press, which is a news organization known for their reliability and their international network. After spending some time there, I decided to do my own kind of business, you can say. I was working as a consultant for 2 years, mostly for US and European clients. But by that time, I was kind of bored with the work that I has been doing for around 5-6 years. It was mostly web engineering and cloud ops. So I wanted to basically learn something new, and I started searching for master's program in data science and machine learning, mostly in Europe. And during that time, I got this life-changing opportunity, I would say, to continue my master's in Finland with Ediss. For the second year, I studied in Sweden, Mälardalens University, and I did my internship in Ericsson on explainable AI. After that, I continued with Groke Technologies as a thesis worker, where my main topic of the thesis was to basically understand their existing databases, do the analysis, and then move the data to cloud, particularly on BigQuery. And a part of the thesis was to explore how we can extract some business values using machine learning models. And on my completion of the thesis work, I joined Groke Technologies as a data scientist, and this is my current role. All right, a little bit of background about what the company does, and then I will try to connect this background with the work that I did during my thesis and what I do nowadays. So Groke Technologies, mainly the company develops digital products for maritime navigation, which means they work with hardware and software. And the hardware part that they call sensor unit is installed on the front of a vessel, and by vessel I mean a ship. So for example, a cargo vessel, which is used to carry tons of goods from one place to another, also needs to ensure that the navigation is going to be safe. So the International Maritime Organization, which kind of regulates this whole maritime industry, requires vessels exceeding 300 gross tons to have a navigation system. The traditional navigation system, I'm not going to talk about it, and honestly, I don't know that much about it, but the system that our company sells is mainly about situational awareness system, which means a bunch of cameras sitting right in front of the ship, and it kind of records the live view that the ship is that the ship can see. So it's kind of providing eyes to the vessel, to the ship. And Groke Technologies, through those cameras and that hardware on board, eventually collects a lot of data onto their cloud platform. So the idea was to take that data, do the analysis, move it to a cloud storage, for example, BigQuery, so that reporting can be done, some customer insights can be done, and some data analysis can be performed to optimize operational efficiency, try to look for opportunities if some fuel savings can be done for the customers, and eventually contributing towards the sustainability. The first part is about data analysis. When I started, they were working with timescale DB and MongoDB. So the data was in raw format, but it was split and was not residing in one place to carry out the analysis. These two terms, dimensions and metrics, these are two important terms when you work as a data analyst. It can be a standalone role within a company, or it can be a shared responsibility if you are working for a startup. That was my case. Initially, we defined some of the requirements about situation analysis for CPA. But what does that mean? Situation analysis means analyzing a situation if the vessel is going to be in a safety critical situation. And if that happens, the automatic system on board triggers an alarm. We call it closest point of approach alarm, that tells the captain that something bad is going to happen and you should be careful about it, or at least you should take some extra measures. And in order to identify that, captain has some training and there are some rules about it. Those rules are called call reg violations, if any regulations is being violated. The third one was highlight high traffic areas. By highlighting high traffic areas, we can optimize the navigation style, and we can also look for opportunities where fuel can be saved. If the waters are congested, it is going to require some extra maneuvers to safely drive through those areas. In order to basically measure these requirements, we need to have some dimensions. So how are we going to quantify it? This is how the analysis ensures. So first we quantified the number of targets, for example, and by target I mean the vessel that those vessels that the camera is seeing. So the objects that are around the vessel. If we quantify them based on the number of objects present at a particular time, we can decide if the waters are congested or not. And by identifying that, we can, number one, ensure safety. Number two, look for opportunities for fuel savings. Similarly, before calculating these dimensions, we need to know the jargon that is involved in the domain. So if you look for a data analyst role, data analyst is usually required to understand the business domain, the jargon, and how business value can be derived. So as I already explained, CPA means closest point of approach. Coal reg are basically the guidelines for collision regulation rules. I will be using these terms on the later slides. COG will be meaning course over ground, is basically the direction the vessel is heading. Rolling is side-by-side movement, and pitching is up and down movement that the vessels go through on water. This is what I did and I currently do is the data manipulation part, which is basically using Python and SQL. And what's important here is to understand the technicality and the business value that we can get out of the data. So bucketing is one concept that I learned while I was on job with Groke Technologies. And it's basically we are currently collecting data on a frequency of 1 minute, like one data point per minute. So what bucketing does is it allows us to basically combine the data into 3 minutes bucket, 5 minutes bucket, and then we can also do some daily, monthly, and yearly analysis with the help of combination of these data points. Average speed can be calculated, and then on the basis of average speed, we can deduce some trip and journey related information. By trip, I mean taking ship from Finland, for example, to Sweden, that's like one journey. And the route that it follows, it basically forms a one complete trip. And if the ship is doing that multiple times during a day, that gives you data, that gives you how was the driving behavior, was the speed was like hitting some extreme points or low points during the journey, was there anything, was the fuel is extra used during one single journey. So if the journeys are repeated, then it is easier to analyze them. But if the vessels are heading all the time in different directions, then that analysis will be difficult. That was like one challenge that we still have. So when we do this bucketing with the help of SQL queries, one thing that should be made sure is to have flexible SQL queries so that it can be altered and you can basically use the same query to know the similar details but about different vessels and different journeys. But if everything is already hard-coded within the query, then it is not possible to simply change the query and use it. One way of doing it is in SQL is to use common table expressions. And similarly, if you are dealing with time series data, so you might have already encountered this issue that the timestamps and time zones are like trickier to work with. So whenever you are working with timestamps, one recommendation that I can provide, always go with UTC and it will make your life easier. These are some of the data visualizations that I used at during my thesis work. So the first few paragraphs, the first few basically screenshots, they show the heat maps. The green points, they are like clear waters. There are not that many objects, so it is easier to navigate through those waters. And the yellow points are basically those points where there are some traffic on the sea, but it is possible to still drive safely. Why do I have these kind of heat maps over a geographical map? Because we wanted to give these insights to our customers, and that's where the role of visualization comes in. Having useful, insightful, and easy to understand visualization is part of the data analysis. Even if you have put a lot of effort in doing the analysis, but if you are not able to communicate it in an intuitive way through visualizations to your management or to your customers, it will not be paying off the effort. Some more visualizations where I am basically comparing the duration of a trip and the distance that it covers. So if there is a discrepancy or if there is an outlier, that gives us a hint. I can simply go into that trip and then look at the minor details. Right now, it's only the distance and the trip. So I will only be able to identify a trip ID. But by identifying that trip ID, I can go back into some other visualizations that I had within the same system and can look into the entire journey minute by minute or with some bucketing. For example, 15 minutes bucket and I can do the analysis. These kind of analysis basically help identify the points where operational efficiency can be optimized and fuel savings can be done. So the next part of my presentation is about predictive modeling, where I used a machine learning model and autoencoder to generate latent space embeddings so that I can perform this CPA alarm prediction with the help of those embeddings. That was one use case for the embeddings. Another use case, we wanted to use the same embeddings to perform similarity search. If there is like one situation where there are some anomalies, with the help of similarity search, we can identify the similar situations through this similarity search. So the goal of the entire effort was to basically predict CPA alarms 5 minutes before they potentially happen, and that was just an experimental project. We wanted to see that can we do this with the available data. The answer was pretty convincing that it's possible, but there were some caveats that needed to be done. And in order to make it a production system, we needed to have some extra data with the routes, which is not currently available. So in the picture on the right side is basically one vessel. White vessel is the main vessel that has the cameras on board. It has the sensor unit on board, and these green dots and purple dots and the arrows which are like moving around, these are other objects that the vessel can see. And these objects, and this screenshot is basically taken from our Unity application. This was the ML pipeline that I used. I took the raw data from Timescale and Mongo, I combined them together, then did the data cleaning part, like missing values and outliers, some standard data processing stuff, and after that, it basically the training round is executed, and for every training round, it follows with an error analysis component that you can see at the end of this pipeline. And that error analysis basically helped us fine-tune the models, fine-tune the parameters, so that the embeddings, the latent space that the encoder will generate can be used for CPA prediction and for similarity search and other similar use cases. And this was like a representational learning task where you give the input to encoder, it gives you the latent space, and then that latent space can be reconstructed to analyze the data. If the reconstruction error is low, then it means that embeddings are capturing the details in the data, and this error can be simply a squared error, mean squared error. These are some of the techniques that I used during my thesis work. This outliers of 90th percentile winsorization is basically, I used it to address some of the outliers in the speed values and range values. Speed is the speed the vessel is moving with, and range is the value that the vessel has from other objects. The missing values in the speed and range kind of features, there were total 65 features, but these normal features could easily be fixed with the median of the available data. Some of the values were right skewed features, and in order to fix those values, which means their distribution is like either is on the right side. And in order to make it basically normalize, first I applied this square root transformation, which is then followed by 90th percentile, because the outliers were lying on the higher end. That was the reason of using 90th percentile. And this is also something that I realized, even though these techniques are, they look simple, they look basic, but it is important to understand when you apply them on the data that what effect they can have on the data itself. Because eventually you will use that data to train the model. So if there are some mistakes that were made during the data processing stage, it is going to reflect in the model training, and eventually you will end up with a model that is not good enough to capture all of the details of the data, which was important in our case. I will fast forward it to feature scaling part, where I used min-max scaling and sine cosine encoding. And what I would like to share here is I was dealing with some periodic values. By periodic values, I mean angles. There were some values about course and heading. And although it's a technical term, but if I make it simple for you, it's basically angle values from 0 to 360 degrees. So if I simply apply min-max scaling on a periodic value, it will scale the values on a scale of 0 to 1. On a scale of 0 to 1, 0 and 360, for example, they are like far apart. So if I apply min-max scaling, that will destroy the periodic behavior of the data. That was like a takeaway from the effort that we were doing at the time, that min-max cannot be applied to periodic values because it destroys the relationship. In its place, you can apply sine cosine encoding, which preserve the periodic behavior of the data, and it will keep the values closer. For example, if the angle is changing from 358 degrees to 0 degrees, there is only a 2 degrees change. But if you go with the absolute difference, it will be a lot. So this was the result of feature engineering plus dimensionality reduction. Initially we have 49 features, which were then converted into only 10 features. And in order to validate the results, I used UMAP, which is a non-linear dimensionality reduction technique, and it verifies the results that the normalized features, which were 65 in number, have the similar distribution as we can achieve with the 10 features, which means less compute, and it will be more efficient as compared to using 65 features. This is the last part of what I did recently, and this was a purely a data engineering task, I would say, ETL pipelines. So if you apply or look for data engineering roles, you will see this term ETL, extract, transform, and loading pipeline. This basically answers, it kind of explains the process that extraction means extracting data from the conventional databases, relational databases, where the data is residing in normalized form in timescale and Mongo. We cannot use normalized data to perform extensive analysis and reporting. For reporting, we need denormalized data. So it was decided that we are going to move the normalized data from traditional databases to BigQuery, which is an analytics data warehouse. So some transformation needed to be done, schema needed to be designed. Those details are not here in the presentation, just to save some time and not too complicated for you guys, but the transformations follow the schema rules, whatever schema is asking for, because that is the target format that we are targeting. So that the transformations will follow the target platform's schema. And then we load the transformed data into BigQuery. Once we have the data in BigQuery, we can use any tool. For example, we ended up using holistics.io, which is a visualization tool that you can connect with BigQuery and do the visualization and analysis. But once you have the data in your data warehouse, you can use any visualization tool on top of it. This was the stack that I used. Mostly it was Google Cloud Platform, and these cron jobs was basically triggering some cloud functions. Those cloud functions reach out to cloud databases, Timescale DB and MongoDB. They extract the data and save the data after transformation onto GCS buckets. So now we have the data residing on GCS buckets, which is an object storage. And the format of the data was JSON new line delimited. So this is called JSON-L, which is a very common format when you work with BigQuery. The moment these extraction and transformation routines write files onto the object storage, it automatically triggers an event which eventually trigger another cloud function that loads the data from those JSON-L files into BigQuery. So this is how this entire process was automated. And as you guys know, in order to connect with the database, you always need a username and password. So for security reasons, we were using Secret Manager, which is a Google Cloud Platform service to manage your secrets. In this case, those were usernames and passwords. And Cloud Build was used to automate the entire process, where you have the Python scripts, your code, you push that code to, for example, a development branch, and then it has a downstream process that is configured in Google Cloud. Again, it's a service provided by GCP, and that deploys your function into, that basically deploys your Python scripts onto Cloud Run functions. In a nutshell, Cloud Run functions are basically running Docker containers. These are some of the migration insights that I was moving date and time related data from timescale DB to BigQuery, and there was a difference in the format. Both of these engines handle date time data, so a transformation was needed to be done, and what helped us is understanding that BigQuery uses UTC, and that made it easier to move data from timescale to BigQuery. Then both of the data engines, timescale and BigQuery, they use different geographical data formats. In timescale, we were storing data in extended, well-known binary format, which is basically alphanumeric data of, let's say, 30 characters or more. But in BigQuery, it was only WKT format, which is a well-known text format for storing geographical data. By geographical data, I mean longitudes and latitudes. And in BigQuery, you can simply have them in a simple format, which is basically enclosing your longitudes and latitudes into parentheses, and that's it. The third intake was long-term data storage. This is something that you will guys encounter when you start working in a data role for companies, that they do care about their cost optimization. So understanding active and passive storage classes will definitely help you when you are designing your data schemas. And for schema updates in BigQuery, there are two different levels. One is like the dataset level, which can be done easily, and the record level, which has some complications like copying data into new schemas and then adding new fields as well. So that was the insights from data migration, and that's it.
Thank you, sir. Yes, question.
Very nice, thank you. Very also thorough overview of what different technology you can use from AI to cloud services and so on. So, oh yeah, sorry. So one thing that I found myself is latency. So the problem you might have are several problems with latency. For example, while you wanted to find the alarms, you say in 5
minutes before.
Yeah. But the point is, how fast is that, right? So how fast is like running the whole machinery, the autodecoder, and that should be done online, or how? Let's say latency is really a problem, and latency is another problem with clouds. When you go back and forth from the cloud with different functions, then you might need to control for latency. Did you consider this in your work?
Yes, I do understand your question, and I think it's a very good question, because we are dealing with safety. But this was an experimental project, so we basically did not deploy it to production, which means it's not running anywhere at the time. But the question still stands valid, and this needs to be basically taken care of in the architecture. But initially, the idea was basically to apply this autoencoder architecture and have the embeddings ready. Once we have the embeddings, I think that will save us some time, because now there will not be any retraining of the data unless new data arrives. And the data that we collect is not very dynamic. Usually they are like numbers, and they are like very close. So I would assume that after the complete training, we can simply use that pre-trained model to deduce the results.
Yeah, thank you for the great presentation. My question is, what are some of the technical challenges that you face as a data scientist, and what are some of the technical skills that you would recommend to current students to focus on developing if they want to take up data science roles upon graduation?
All right, good question. If you are planning to pursue a data scientist role, then you should have a good understanding of how the data manipulation techniques work. When you process your data and you say, I'm going to apply, for example, the example that I have in my presentation, that I am using winsorization to address outliers. But when you use that, you should also know what effect it will have on the distribution of your data, because eventually it is going to affect the machine learning models. So if you want to pursue a data scientist role, understanding data manipulation, some mathematics, and how actually machine learning models work, it is more important than going after some fancy architectures and fancy terms, because when you are being interviewed for a data scientist role, they expect you to know some statistical machine learning, on top of that some deep learning stuff. Hope that answers the question.
Do we have one more question? Yeah.
Hey, thanks for the presentation. Just a question out of curiosity, because you said something related to the predictive modeling, and you were trying to predict the vessel trajectories and movements, if I'm not wrong.
Sorry, I didn't catch it.
No, I mean, you were talking about predictive modeling, right?
Yes.
Using multiple models for doing this. And you were talking about a very high accuracy value. So I just wanted to understand, one, do you observe some kind of drifts, right? I mean, because usually when you deploy this, there are uncertainties that will come in and your actual prediction might deviate from your original, values that initially you had. And what are you doing to kind of encounter this? Because it's not like you deploy the model and you say, okay, it's done, right?
Yes, good question. So once we have that latent embeddings ready, we feed it to, for example, that's what I did during my thesis work, is to fed the embeddings into an XGBoost model to see how well the predictions can be. While I was training and evaluating how good the XGBoost model is performing in this case, I went with recall as an indicator, not with accuracy. And the reason was, in our data, there were more scenarios where there is no CPA event triggered, so it was safe. So very less scenarios where the CPA is actually triggered. So there was this challenge, and then since recall indicate this true positive rate, so that was the reason I went with the recall to indicate how good the model is performing, because even if I was able to achieve something around 80% recall, which was good given our data and some of the constraints that were in place.
Yeah.
And since it indicates the true positive rate, so saying that there is going to be an event is less costly as compared to saying there is not going to be an event and then there is an event.
Got it.
So that was the reason we used recall for the validation part. Thank you.
No more question? I think we close
Thank you very
here.
much for your attention, guys, and best of luck.
Thanks for all the alumni for being with us today. It was very nice to see all the different type of application domain: banking, health, smart cooking, maritime. I think it's very nice. Do you want to say about the program?
Yes. So we go down. There is a little bit of time for coffee break, but there is also the board games waiting for us. Then we continue it with lunch. The real important time that we need to remember, at 2 p.m., we'll start with the presentations here, with Grace Lewis making her presentation, okay? So see you downstairs.
They have teams that combine all these three into one. But in other organizations, a lot of the organizations that we work with, they can't afford to have data scientists on all of their teams. So they have data science teams themselves, and it creates some of these problems, and that's what we're trying to fix. So what we see, or what we're seeing and still seeing, is that these three different perspectives that I talked about before work very independently. So you have people doing model development. Not always, you guys are different, but typically these are data scientists, very strong statistics background. Some have machine learning degrees nowadays and all that stuff, but their focus is data science. Don't know a lot about software engineering. Then you have software engineers that think they know a lot about data scientists and they don't, but they have their perspective as well. And then you have operations people that are the ones that are going to be operating the system, and they don't work well together. And the problem that we see very often is that, and I feel bad because it shouldn't be this way, but model development teams get very little system context. Go develop a model that does, I don't know, cat recognition. We had an interview study some time ago, and one of the frustrations of the data scientists is that often they would just get a bunch of data, and it's like, here's some data, go do some data science. No system context. And this is very challenging and creates a lot of these problems. So unfortunately, this is how they are developed these days, but you are changing this to make my life easier. Okay, so when we did that study, we wanted to understand if something that we had called ML mismatch really existed. And bottom line, yes, it does exist. So we did an empirical study where we interviewed people from different organizations, Department of Defense, government and industry, and we tried to identify problems that occurred because of those different perspectives, because they were not sharing information. And not only that, but we were able to trace those mismatches, and we call that ML mismatch, but we were able to trace those mismatches to pieces of information that they should have shared, but they didn't. And if they would have shared that information, sorry guys, mismatch wouldn't have happened. I mean, I have resources for this at the end. I'll give you the slides. But basically I guess you can see it kind of sort of well, but basically we codified that information into a set of descriptors, and we built a tool around that so people can capture that information. But the bottom line is that there is a lot of information that should be shared between teams, and it doesn't get shared. And what motivated me to start working in the testing area was that if you look up here, and once you do the math and all that, the lack of information regarding testing was one of the biggest sources of mismatch. What were some of the reasons that were attributed to this? So on the data science or machine learning engineer side, some of the reasons for these mismatches were, I don't have any requirements, nobody gave me any requirements, so I don't even know what to develop. No system context, meaning that they had no idea how the model was going to be deployed. No representative test data. They didn't really have good test data. Or unrealistic stakeholder expectations. I mean, I think that's going to happen to a lot of you, is that a lot of people that don't have a lot of machine learning background, think that models are perfect and they work super well, and sometimes that's not exactly true. So that's from the data science side. From the software engineering side, again, because these are organizations that have separate model development teams, well, the model gets given to the software engineering team for integration, and they don't know what to do. They don't know how to do integration testing. They just don't know what to do with it. Like, how do you test it? Or for example, they have no data for testing. Like, what is the data? Nothing. No model documentation, no specification. Like, how do you develop test cases? And that still is a challenge, but that testing was an area of really a need for a lot of things to happen. So obviously, a lot of these organizations, the problems that they were facing is that the machine learning enabled systems didn't really meet the requirements and failed because they were relying on a model that didn't really do much for them. So I think this is my first question for all of you. And I do expect answers. I don't know your names, but I'll call on you anyway. So in your opinion, based on all that I've said today and based on your own experience, what do you think is the main reason why it's hard to test machine learning enabled systems and machine learning components? Come on.
Hi. I think when the latest model, DeepSeek, the one that hyped up the inter-LLM field, was released, I tried two of its very famous Cohen distilled models on my Mac laptop. And what I realized is they're very easy to jailbreak. Like if I tell them to make my grandma wants to know how to make some psychedelic drugs because she's suffering from World War II or something. it ends up telling me how to make psychedelic drugs. And I shouldn't have been like seeing the response, but I ended up knowing how to make them. I realized that when we are making the models like more quantized or distilled for like local use cases, we often prioritize on accuracy of the models. We often prioritize on like evaluation metrics like accuracy,
Okay,
or
accuracy.
how similar the response is to the actual model in some cases, but what we fail to test oftentimes is whether the model is properly aligned with its base model. And alignment testing is not easy.
Yep.
Although we also have some metrics for testing the alignment, but do those metrics like truly represent or are they generalizable across like different models, or there are different scope of use cases for the alignment? It's very hard to test, and I often find even the top tier models like CodeStral from Mistral and even OpenAI like often struggling to make sure that this alignment is, how can I say, like consistent across all of its model. So that's also one of the core options. Like we don't have the proper evaluation or benchmark frameworks for testing the ML-enabled system for all the cases it should cover.
Yeah. So if I were to summarize what you said, the first thing you said is that it's very easy to break them. So basically, it almost seems like we're not testing them enough. And the second thing you said is that we're used to testing for accuracy, but that's it. We don't look at the other system qualities. Yes? Was that a good summary? Oh, sorry. No, it's okay. Alignment. Okay, no, okay, I got it. Yeah, thank you. I missed this. There was a third one. I missed it. That's fine. Go. Okay. I mean, who has the microphone? I don't know who has the microphone.
Yeah, I have microphone as well. I wanted to say that one of the reasons, in my opinion, is the one that you mentioned, that it's not very explainable, and as a consequence, and it's also not deterministic. So when we give the same value, yes, we can expect the same result from model. But if the value a little bit changes, right, the result can be completely opposite, right? So you can give a sentence, and the model will give the expected response, but then you change one word, and the response completely different. And I think that while there are classical components that behave that way, like chaos theory and so on, it's not very widespread. And in ML, it's everywhere.
Okay.
Hello? Yeah. So what I think is not all the machine learning models are same. For example, if you have supervised learning models, there is a way to test them based on the label. But for unsupervised learning models, there's no way to test if the clustering is accurate. And also let's say elephant in the room, LLMs. They do generative work, and every time you do a query, if the query is the same, they give different results every time. So as a human, you can say, okay, this result is working or this result is not based on your experience, and also testing. Let's say if there's a code, you can just run it and test. But it's not, I mean, they are not deterministic, that's what I want to say. And they are not deterministic, and because of that, there is no way to, what I think there's no way to see that if the response which is giving is correct or not.
Right, right. Yeah, and as a matter of fact, there is a standard that a lot of us in software architecture are very familiar with, 25010. They released, there is a version that's just targeted at quality attributes for AI systems, and they, functional correctness, they redefined it as it performs within a range to deal exactly with what you just said. So they redefined functional correctness, yes. One more, because I do have to go on. Go ahead.
What I wanted to emphasize in this case is that software engineering practices, like more traditional algorithms, usually work more like a blueprint. Basically, the steps are pretty clear, and you know that the code will most of the time execute the same way unless you have a bug or a problem. But if it's correct, it's pretty easy to test it because you know what to expect. With machine learning algorithms, the way that they work, it's often very probabilistic. So they will not take the same path of execution if you go into the neural network, for example. It will take a different path. The result could be the same, but the fact that it will take a different route to go to the same result makes it different for you to predict always, and the shifts in the results reflect that in the end.
Yep, absolutely. Okay, there are many other opportunities for questions. I have like 10 of them, so don't worry about it. So here's these are very good friends and colleagues of ours, but here is a paper from what year, 2022, where they did an empirical study to understand challenges related to machine learning testing. And I have to say, you did very well in answering their questions because I think you covered most of them. Data and models cannot be strongly specified beforehand. They don't have the blueprint. You said blueprint. They don't have a blueprint. This is more specific to models themselves, but scalability when testing model parameters and hyperparameters. You talked about the fact that like coverage and being able to cover every possible path. Overfitting model to training data, that's a known issue. Lack of data, actually, in our experience working with organizations, this is probably the hardest, is the lack of data. Traceability of experiments. What does coverage mean? Some of you talked about neural networks. Not well-defined testing processes, you said that. Many targets for testing processes, and also the lack of testing tool support. So you did very well in your answers, thank you very much. So let's go back to this idea, because I want to build on what you said, which was that typically people that are developing models test just for accuracy, and they don't test more. So where do model requirements, where do ML component requirements come from? So let's start over here at the top. So in a typical, very simplified software development process, you have your ML-enabled system, you have requirements, architecture design, test and evaluation, and you repeat this many, many times. So what happens is that, like I said before, what should happen is that during the architecture and design aspect of the development process, you have to do system decomposition and assign responsibilities to components. Okay, this component does this, that component does that. Oh, it so happens that this component should be, or I think it should be a machine learning component. So when that happens, I kind of have to repeat the same thing for the machine learning component itself, right? And so, like I said before, some of these components are going to be machine learning components, and then they derive the requirements from the system. In our work, we call those system-derived requirements. And once you repeat this also many times, the results of test and evaluation of these machine learning components feed back into requirements engineering. So basically, you keep on repeating this process for as many components, ML and non-ML, right? And what I want to talk about here is this idea of system first and model first. What I mean by this is that another study that we did, we identified that nowadays, actually things are changing a lot with LLM, so I'll have to, that's a caveat there, but it is rare to find greenfield. Are you familiar with the word greenfield? Greenfield is when I start a system from scratch. It is not very common for machine learning enabled systems to be greenfield. They are, especially now with LLMs, but it's typically, I have a system and I used to do things in a certain way, but machine learning came along and I can do this better, I can do this more efficiently with machine learning. So basically you're replacing a traditional component with a machine learning component or components, right? We call that system first. But there are also organizations that take a model first approach, meaning that they first develop the model, this is so typical with LLMs today, and then I build a system around the model, right? Nothing wrong with that, but it's just a different way of doing things. And what I'm saying here is that even if I'm doing a model first approach, I do have to think about the system that this model is going to reside in. So for example, it's typically nowadays with LLMs, right? Chatbots are the big thing, right? Even if I'm building the LLM that is going to sit behind a chatbot, I need to think about how people are going to interact with the chatbot, logging, monitoring, user interface, et cetera, et cetera. So even in those situations, you do have to think about the system's perspective. That's all I'm saying there. Now, going a little bit deeper into that diagram, if I think about the requirements engineering phase, and this is I'm talking about the bottom portion of that diagram from before. So what is going to happen is, as I decompose or think about the requirements for the machine learning component, some are going to be functional requirements. It has to identify cats, it has to do this, it has to do that. Some are going to be quality attribute requirements or non-functional requirements. It has to be robust, it has to be secure, there has to be privacy, et cetera, et cetera. And others are operational environment requirements. It has to be able to run on a drone, or it has to be able to recognize things in these different situations. So those are the operational environment requirements. And so what happens with that is that when I go into my ML component architecture and design, what defines my ML component, not just my model, the ML component, is derived from these three types of requirements. And then here, what happens during that phase is that some of those requirements are going to translate into training data specification, because if I need a model to do X, I need to provide training data such that the model can do X. So I use those requirements in that architecture and design to specify training data for that model, but also to specify the model in the data pipeline. But bottom line, you already know all this because all of you have taken all these courses. After I do model training, I have a machine learning component that then goes into test and evaluation, right? And the point that I'm trying to make here is that the same way that these requirements define the architecture and design, they also define the test specification so that we can test against those requirements. And just something to point out is that your operational environment requirements are what is going to dictate your test data collection, mostly. I mean, obviously these will as well, but mostly it's going to be your operational requirements. Okay, questions so far before I go into something called MELT? That was a lot of background, but I needed you to understand where I come from. Good? Okay. Because I do have questions for you in a second. So something that we've been working on at the SEI for the past 2-ish years is something called MELT. I know it doesn't say MELT, but we call it MELT. ML test evaluation. And it's a combination of a process and a tool set. It's open source if you want to try it out. It's available there. But I don't want you to convince you to use MELT. I mean, it would be great, but I don't want to convince you to use MELT. But what I want to do is I want you to understand the concepts that went behind developing MELT and how you should apply those concepts in your journeys going forward. So MELT is, lots of adjectives here, it's system-centric because it forces model developers to think about the system. It's quality attribute driven because it forces model developers to think beyond accuracy. Semi-automated, and I'll tell you why in a second. And what does it do? It enables negotiation, specification, and testing of ML model requirements. That should say components. The other thing that MELT does is it produces evidence of testing activities, which is important, especially in those cases when you have separate teams. We developed this with an Army organization, AI2C, and they use the process within the organization with very good results, like I said. So the key elements of MELT are, or the three things that come out, are stakeholder negotiation. So this emphasizes the fact that model development can't happen in a vacuum. It needs to happen within a system context. This is what this piece means. This piece over here recognizes the fact that model development is not like your traditional development, in the sense that it's very iterative, it's very experimental, it's very almost trial and error in a way. I mean, in a way. So it recognizes that that happens and that there is some test and evaluation that happens as part of that activity. And then the system-dependent model testing, or SDMT, this is where the testing against those quality attributes happens. So it emphasizes, look, when you're developing, there has to be some testing, but once you're done with that, we really have to really test this machine learning component. And the center of all this is something that we've called the negotiation card. Are you all familiar with model cards? Some of you are nodding. So if you think about model cards, this is something that came out of ex-Googlers on how to document models. It's very similar, but what the negotiation card does is it records the results of the negotiation, okay? So throughout this, the rest of this talk, the ML-enabled systems that I'm going to talk about, this is a semi-fictitious system. It's called the Garden Buddy. And this is a system that is used by people as they walk through a garden and to identify flowers as they walk. And so they take a picture of a flower and the system tells them, okay, you're looking at a lily, or the scientific name for lily, and it'll tell you other things about flowers. And this particular system uses an ML component for the flower identification part, okay? So the Garden Buddy is the system that we're going to use as an example. I do have many slides that go with this, but this is what melt looks like. And what I'm going to do now is I am going to go step by step into the things that happen during the execution of melt, but again, not to convince you of the tool itself, but of what needs to happen. So let's start with number one. Number one is up here. So the first part of melt basically says there has to be a continuous negotiation process with stakeholders throughout model development, meaning that they have to be treated like any other system component. They're not special, a little bit, but that negotiation needs to happen the same way that it happens with any other type of system component. So what this part of melt addresses is something that I already talked about a little bit before, that very often ML component developers don't get any system context when they're asked to develop a model. They don't get any system context. This is especially true in organizations that have separate data science teams. And when I say separate data science teams, it can either be, they can be internal to the organization, which is very common, but they could also be external because they don't want to keep that expertise in-house, but they outsource it or they subcontract it, et cetera. And this, in our experience, leads to ML mismatch, and we already talked about ML mismatch. Because model developers don't have this system context, what they do, and you said this before, or maybe the gentleman behind you, was that testing is limited to some statistical tests related to model performance, most typically accuracy, and that's a problem. And so by doing this continuous negotiation, treating ML component development as you would treat any other development and making part of the system development process, what you're ensuring is, first of all, is that the system context is shared, because as you'll see later, the negotiation card has some very specific things, which basically, until you tell me all this information, I'm not going to develop your model because I need this information. The other thing is that both the development and the testing are guided by the system context, so that is how we define the test and the development. And the third is that as the model is tested and the test results are recorded, they're also driving requirements back and forth. So for example, from a system perspective, your stakeholder says the model has to be 95% accurate and run on a cell phone. You could say, whoa, no, not possible. Look, this is what my testing is telling me, and we're going to have to reevaluate these requirements. Okay? Any questions so far? Okay. So now I'm going to get into quality attribute scenarios. How many of you have already taken a software architecture course? Oh, less than half. Okay, that's okay. No problem. This is my world. Okay. So model requirements are driven by something called quality attribute scenarios. This is something that was developed at the SCI many years ago. But what it does is it helps make requirements specific. Before joining the SCI and doing research, I was in industry for a while, and I know that very often you would see these requirements documents that said, the system has to be usable, the system has to be secure. Okay. I mean, what does that mean? And so what quality attributes help you do is to say, okay, when you say secure, what exactly do you mean by secure? And then you kind of like tease out your requirements. So, like I said before, developed at the SCI, I don't even know how long ago, many years ago, before my time. But they guide the elicitation and documentation of these system-derived requirements. And so, once you have quality attribute scenarios, we call them quality attribute requirements, non-functional requirements, system qualities, we talked about that. But the goal of using quality attribute scenarios is to ensure that they're described in a way that is unambiguous, but also testable, because it forces you to define some pieces, I said before. What do you use quality attribute scenarios for? You use it to communicate and negotiate with stakeholders because it's in a language that they can understand. It guides model design decisions. It helps you reason about those trade-offs, like what I said before. And also it helps you build test cases. And this is the part where MELT really builds on quality attribute scenarios, which is to help develop test cases. So, am I making that noise? Oh, okay. So, a scenario has 6 parts, and this is how you define, in our opinion, quality attribute scenarios. Sorry, it went away again. Yeah. So the first part of the scenario is a stimulus. Like, what is it that is coming to the component, in this particular case, ML component that you're testing, that the ML component has to respond to. So it's a condition arriving of the system. It could be an event, a user operation, attack, a request for modification, but there's a stimulus. And there's a source of stimulus. Like, where does that come from? Which is this part up here. So there is something that produces a stimulus that the artifact, this is what you're testing in this particular case, has to respond to. So that's the artifact that's the target of the stimulus, and the environment is the set of circumstances under which that stimulus occurs. So you could say normal operations, or when the system is overloaded, or where the system is under attack. Those are 3 examples of environments. And then when that happens, this is the response that I expect from that particular component, and this is the response measure, and that's what makes it testable. If you're interested in this, I mean, this is the software architecture Bible. Is that a proper way to say it? If you're interested, that is the Bible. Anyway, so to give you an example of this is a very traditional performance scenario. So the source of this particular scenario is a user. The stimulus is that it initiates a transaction, and when the system is under normal operations, transactions are going to be processed with average latency of 2 seconds. That makes it very clear and very testable. So when I say it has to be fast, this is what I mean by fast. I mean that all transactions have to be processed on average latency of 2 seconds. Okay? Questions about scenarios? It's pretty straightforward. It just helps you really get to the details. So how do we apply this, which again traditionally has been used at the system level? How do we apply it to machine learning components? So in this particular case, for our Garden Buddy, this is a robustness QA scenario where we say, okay, the model has to be robust. Okay, what does that mean? So the quality attribute here is the model is robust to noise, and in this particular case, it's image blur. So the way that I would construct the scenario would be, okay, let's think of the stimulus. So the stimulus is that a machine learning component receives a blurry picture that was taken at the garden. Where did it come from? From the flower identification application. This occurred during normal operations, just so regularly. The artifact is the machine learning component successfully identifies flowers, and the response measure is at the same rate as non-blurry images. So now I have a very clear and testable requirement, which is the model receives a blurry picture taken at the garden from the flower identification application during normal operations. The model successfully identifies flowers at the same rate as non-blurry images. That's a requirement. Question?
My question is, so define blurry basically. Define blurry basically. So the idea is that the stimulus says that you receive a blurry picture, right? What kind of blur?
I'm gonna get.
Okay.
I'm gonna get there, because actually hold your question, because that's a really good question. Was there another question? Oh, I thought that was a microphone. That's a water bottle?
Mine is a question, but I want to also confirm, because the description is similar to what the principles of site reliability engineering by Google, where you define some metrics, and then you make sure your system is centered around those objectives, which is SLO, to make sure the objectives measure the metrics for the.
Yes.
It's like the same principle?
Yes,
Okay.
absolutely. Same principle, thank you. That was a good clarification question. Okay, so this is an example of a quality attribute scenario for the flower identification model. I think this is my second question. Yeah, so just to make sure that you understood what quality attributes means, we're not going to define them during scenarios. This would take us forever. But thinking of what the Garden Buddy does, or at least what you think it does, because this is how requirements start, what are other quality attributes that you think would be important for the Garden Buddy, for the model in the Garden Buddy? Response time. Why is that important?
Well, now I need a microphone. Because if the user waits 5 minutes for flower to be identified, the app is useless.
Absolutely. There's one back there.
Maybe, sorry for my voice, that it should work both for daytime and nighttime?
Absolutely. That's another example of robustness. Correct. What else?
differences in different mobile phone camera sensors, sensor noise.
Now you're getting really, okay, difference in mobile phones, absolutely. Yeah. And see, for model developers, that never shows up as a requirement, ever, and that's the problem. Okay, one more, and then I'll show you the requirement, like the real requirements at the end, and you're spot on. Okay, that's fine. Nobody else? We're good. Okay. So, we talked about negotiation. That was number one. We talked about quality attribute-driven requirement solicitation. That's number two. And now I want to talk about the negotiation card, because the idea behind the negotiation card is that it records all these conversations that happen during this negotiation process. And the reason why this is important is because if you have all this data, and I'll show you in a second what the data is. It's going to help, because you see it shows up here again. It's going to help people developing the model, because now they're making more informed decisions. So you said something about the mobile phones, right? If I know that the model is going to run on a mobile phone, I might make very different decisions about the type of underlying algorithm, because some will not run on a mobile phone, for example. So it informs model development, but it also definitely informs this part over here, and this is probably the most important part of MELT in my humble opinion. Okay, so the negotiation card, like I said before, it was inspired by model cards. Some of you also may be familiar with data sheets for data sets. Same thing, one documents models, one documents data. And what the negotiation card does is it records the outcome of these discussions that we have with stakeholder context. And because it's part of the process, they can be revised at any time. If data results show that the model is not going to run on this particular mobile phone, then you have to reconsider requirements or anything like that. So the major sections of you guys are going to laugh at this, but I was actually going to do a demo, and I can't do the demo because I didn't pull the right version before I left the US. And I can't do it from here. So I made a big software engineering mistake. But if you do it, if you downloaded the official version, you can do it. But I can probably show a little bit of the demo. It's just one of the tests is going to fail. But anyway, so in system context, it asks things like, what is the task that the model is going to perform? What are the technical goals for the model? What are the business goals for the model? And that's important, and I'll tell you in a second why. What is the usage context for the model? Is it going to be deployed and people are going to use it via an API? Is it going to be deployed in the cloud? Is it going to be like just the usage context for the model? The risk of false positive and false negatives. A model developer needs to understand what that risk is, because again, they'll make very different decisions based on this information. It asks questions about the data that is available. What data is available for me to train the model as a model developer? What are the labels and what is the distribution of that data, if it makes sense? I mean, obviously in unsupervised there are no labels. What is the data schema? That also came up, I mean, actually this happens since the database days. This is nothing new, but model developers get data, and it's a comma-separated value, a CSV file. They have no idea what the fields are or what they mean. And they are supposed to train a model on this how? So this helps clarify that, meaning no, tell me what each one of these pieces of data is, and then I can start my model development. So it talks about data. As far as the model, it talks about what are going to be my training compute resources, what is going to be my deployment platform, is it going to be a local server, a cloud server, an embedded platform, what is my capability deployment mechanism, API, user-facing, data feed, what is my input specification, and what is my output specification. This was another huge, going back to the diagram that I showed before, the one with all the colors, this was the second reason for mismatch. They're developing a software component because it is a software component, and nobody told them what the API was going to be. That's typical. And also the production compute resources. Once it's been trained, where is it going to execute? And also the system-derived requirements, but we already talked a lot about those. But the negotiation card records all that information, which is very crucial for somebody who's developing a model. Okay? Checkpoint number 3. How does model development evaluation change if presented with this information? If you are told that the model is going to be part of an application that runs on a device loaned out by the botanical garden so that visitors can identify flowers during their visit, how would that change the way you're doing model development? Like what decisions would you make? What questions would you ask the stakeholders if they told you, oh, by the way, it's going to run on these devices that we have that we loan to people at the garden when they enter the garden? That's a very good question. Go ahead.
Whether the device will have access to internet or not. Whether the device will have access to internet or not.
Oh,
or whether a model is running locally and, yeah.
Yeah. Is it going to run locally or does it have access to the cloud? Absolutely. You had a very good question. What does this device look like? Yeah?
Also, battery and energy requirements for the device usually are a big limitation for these things.
So limitations, let me expand on it. In terms of resources, like how much memory does it have, how much disk, how much battery, how much...
Yeah. Specifically battery, because it has to be around the garden, it can't be connected.
Yep, absolutely. Anything else? Okay, I have another question coming up. So what would you start worrying about as a model developer if, when you ask about business goals, the stakeholder tells you that the business goal is that the application is going to increase the number of repeat and new visits to the garden? Like basically, no pressure, but your application is going to help my business get more customers. How does that change? That's always a good question. How exactly do you think it's going to help? What else?
I would want a more engaging customer experience, maybe create accounts for the customers and remember some of their data, for example, if they want.
Anything else? So
Can I also
okay.
maybe some hint about how the flower or the plant will evolve over time to, come back in 3 months and you will see something else. Or...
No, that's a good one. So let me tell you, what if you loan this device and you start using it and it tells you that a rose is a lily and a lily is a lilac and a lilac, would you come back? That's really bad user experience, right? Huh? So that asking about business goals also help you in that, because all of a sudden, again, no pressure, but accuracy does become very important because they're expecting this to increase their visits, their sales, etc. So again, it's important for normal systems. It's also important for these systems.
My question is it the data scientists who need to infer from this information that accuracy is important? So who is responsible for saying, okay, since we want high visitors, we need high accuracy?
Yeah.
Accuracy.
No, it's a very good question. And I would answer that it's true for not just for model developers, it's just that maybe their background isn't there. But the most important thing about quality attribute scenarios is that it forces the conversation. So for example, your first reaction is like, wait, whoa, what do you mean? So having that conversation is what, so no, I don't think the data scientist is responsible for saying, oh, you mean it has to be more accurate? Maybe yes, but it's the conversation where you're like, okay, I get it now. It can't fail because then
Thank you.
But this is true of any software component. Okay. So with that, 3:30, right? Okay. Yeah. Okay. So now we get into IMT. So as I said before, IMT recognizes this very experimental nature of model development. Now, the thing here is that, as you will see here, is that now the negotiation card does have information that is going to be used by model developers as they develop the model, they collect performance metrics, and they compare against their baselines. It's going to be able to know information about the data available, the metrics, the baseline, and rationale. So rationale, when we did the study with the AI2C Center and when we were developing the tool together, one of the things that was very important for their data scientists was to record rationale. And what I mean by that is when the stakeholders would say, this model has to be 95% accurate. Why? So getting the rationale. Well, no, why? Well, I read this paper and it said that there was a computer vision model that performed well, and okay, I'll write that down as rationale, but keep in mind that this is not a computer vision model, this is something else. But again, it records that. Rationale was very important for them in this particular, and so the tool records rationale. But anyway, as I go through this, then, if the performance doesn't exceed the baseline, I just keep here, which is a lot what data scientists do, but eventually, one of two things is going to happen. Either the performance exceeded the baseline, so good, or it's like, this is as far as I can go. Let me see how it does against all my other quality attributes. And that's when I go to SDMT. So, like I said before, this is the testing that occurs as the normal part of the development process. It recognizes the experimental nature of model development. It is informed by the negotiation card, which is important. And as I said before, when do I stop? When my model performance exceeds my baseline, or when I need more information. This is as far as I can go. I can't get it to be 95% accurate, so I'm gonna stop here. Okay. So now I'm actually gonna talk about all this together because this is where I'm gonna spend most of my time, I think, today. So SDMT, this is this box over here. What it focuses is on obtaining evidence that those system-derived requirements are satisfied. It uses test cases the same way as in software engineering. Again, for data scientists, test cases, they're not part of their education. That's fine, I understand. They're not used to talking about test cases and test specifications or anything like that. But test cases are first-class artifacts, meaning that the test cases are defined within the tool using the MELT library. And the testing evidence is collected via text execution. So every time that the tests are executed, those results are stored so that, for example, somebody can also observe the results of that testing over time. So I'm going to be talking about, I'm going to be talking about this big piece. I'm going to be talking about 6, which is here, and I'm going to be talking about the collecting evidence, and then I'll talk about the other pieces. So SDMT, it focuses on obtaining evidence of the satisfaction of those requirements. The goal is to collect evidence for every one of those system-derived requirements that I specified. And now what I need to do, it requires translating QA scenarios into ML component test cases. And we also have a process for that. In MELT, in case you're interested in using it, again, doesn't matter, is each case is implemented as a Jupyter notebook. So for each test case, there is a Jupyter notebook. So we're also kind of enforcing good software engineering practices, modularity and all that stuff. And maintainability. And the way you specify a test case is using the MELT library, where you establish what are your metrics and your passing conditions. You write the code for collecting the measurements for metrics, for validating the measurements against those passing conditions, and for storing those test results. So there's a structure to each test case that is also provided by the tool, which also, again, provides the discipline to the person that is developing the model. So how do you translate these QA scenarios into ML component test cases? So in your stimulus and your stores of stimulus, basically for a data scientist, what that translates to is what is my data and what is my data source? So how does that translate to ML test code? Well, I need to identify data sets that meet the specified characteristics in terms of quality and quantity. Like, I have to gather the data such that I can test that property, and I'd have to generate or transform the data to meet those needs. So the stimulus and source of stimulus translates into the data that I need to gather to be able to test this. As far as environment, it becomes like the context, like what do I need to replicate? So for example, if I want to see how the model performs under stress, I have to simulate stress conditions, for example. The artifact is always going to be the ML component under test, so nothing there. And the response and response measure, basically, you have to figure out what is the test to meet that response measure. I have to set up the test, and I need to define the conditions for the test to pass. Let me give you an example, because it's much easier with an example. So if you remember, and this is where you're, I want to call you Super Mario, but your name is not Super Mario. But so the question that you asked. So the quality attribute was robustness, model robust to noise, image blur. I'll read this again because it was a couple of slides ago. The model receives a blurry picture, you asked what was blurry, taken at the garden from the flower identification application during normal operations. The model successfully identifies flowers at the same rate as non-blurry images. So, as a model developer that needs to test and needs to write a test to prove that this is true, then basically what I say is, the test data is going to need to include blurred flower images. So what I'm going to do is, there's a tool out there, it's called Image Magic, open source if you haven't used it before. I'm going to take images from my test data, and I'm going to blur them using this tool, and I'm going to generate 3 data sets. I'm going to generate one with minimal blur, I'm going to generate one with maximum blur, and I'm going to generate one with in-between blur. And so basically, I've constructed my data set. And as far as my measurement and condition, the scenario description says, successfully identify flowers at the same rate as non-blurry images, so I can say, okay, so the blurry images should be identified successfully identified at the same rate as my normal images. And the way I'm going to do this is using the Wilcoxon rank sum test with a significance at p-value less or equal to 0.05. Again, that is what data scientists speak. Somebody had to explain this to me. But this is what they do. This is what they do best.
My question is about how, again, specific the value should be. Because, yes, minimal, it's basically the same question I had before.
Yes.
Now I personally think I understand what's minimal blur, maximum blur, and between. But again, between where? In the middle, not in the middle. And I can be asking those questions a lot until I get the exact blur values.
Yeah.
So is it the goal, like ideally it should be very exact numbers, or this way of definition is fine?
So for example, I can start with very vague numbers, right? And it's the result of the testing that is going to tell me how it's done. So for example, let's say you do something, your test don't, I'm assuming you're the data scientist here, your test don't pass. So you can go back to the stakeholder and say, so when you say blurry, what exactly do you mean by blurry? And maybe the person will say, oh, when it's a cloudy day, the pictures don't come out so well. And that's what I'm concerned about. And then you can say, okay, I get it. So I'm going to generate the images differently. I'm going to whatever, but it triggers those conversations.
So how much of this should happen? Because it sounds to me very much like negotiations that should happen before any development started at all. So basically there are 2 types of negotiations, right? Before anything happens and during this iterative process.
Yes.
Right? So how much information should be defined ideally, before, and how much should be defined during the testing?
I'm a software engineer. You know what my answer is going to be, right? It depends. No, seriously, it really depends, because it depends on, one, what is considered success for your customer, the garden owner, etc. Yeah, it depends. It really it's like, again, like what I after this is all done, and I'm kind of stealing my thunder because this is going to be in my last slide. What I want to convince you today is that just because we're developing ML components, we don't have to throw away all the software engineering that we know. The software engineering still applies, still does. And what the questions that you're asking, I asked them 20 years ago when I was developing software. So it's normal. It's just part of the development process. Okay?
Okay, I see. Thank you.
Okay. Okay. And another thing that for the organization that we were working with was very important was this idea of a test catalog. And where they were coming from is that when you need to write a piece of code, well, I know now you ask ChatGPT, I get it. But you in the old days you used to go to Stack Overflow, but that is so old school, right? But you would go to Stack Overflow to find code, and their concern, to put it that way, was there is not a Stack Overflow for test code, especially for model developers that don't have that background, that knowledge of what test code means, or maybe even of quality attributes. So the idea is that Part of MELT is also providing that test catalog, which we call it the Stack Overflow for test code. But for an organization, a developer within an organization can say, let me see what other quality attributes have been tested and maybe get some inspiration, or how, when people said robustness, how exactly were they testing robustness? So that's basically what the test catalog is. And so what it does is it contains reusable examples of test cases organized by quality attribute. It supports SAML component developers that are really not familiar with this vocabulary of quality attributes, or maybe haven't really done this before, haven't tested beyond accuracy, which again is pretty normal. And the idea with the test catalog is also that as they write their own test code, they can contribute it back to the test catalog. So what happens over time is that as an organization, I start to collect that organizational knowledge of how models are tested within my organization. And so to give you, I just want to give you an idea because some of you were curious about the quality attributes. So for the Garden Buddy, we identified 11 quality attributes. The first one was fairness, which was that the model is impartial, and I have a slide for each of these, that the model is impartial to photo location. I'll tell you what that means in a second. The second one, we already talked about it, model robust to noise. But it so happens that these devices that are loaned out by the Garden have another source of noise, which is channel loss, because they're not very high quality. And so the model has to be robust to channel loss. As far as performance, resource consumption of the operational platform, inference time, one of you said response time, interpretability, understanding model results, and I'll tell you why that was important for the Garden Buddy, functional correctness, your typical things, accuracy, input and output specification, resilience in terms of input validation, and monitorability, very important, detecting out of distribution inputs and detecting basically output distribution errors. So, model important to photo location. The reason this was important is because the models have lots of gardens. Botanical gardens have lots of gardens, right? They have the rose garden and they have the tropical garden. I'm trying to think of the one at home. They have a tropical garden. They have the desert garden, where the cactus are and all that stuff. So, and the idea is that the model should be able to recognize flowers independent of where they have been taken, because you don't want any imbalanced data sets, basically, for example. And so this is what fairness means in this context. And so there is a scenario for this, and there is a specific test for this to be able to make sure that is correct. Again, I don't expect you to read all this. I'll leave you the slides behind. It's just so you can get an idea of the requirements that were necessary for the Garden Buddy. We already talked about this one, so I'm going to skip it. The model robust to noise, to channel loss, and like I said, these devices are known to sometimes lose a channel. They're not very high quality, so the model should still be able to identify flowers regardless of that channel loss, and there's the process for producing that. Performance, it talks about the resources that are available on these small platforms. So limited CPU power, limited memory and disk space. So obviously, as a data scientist, I do have to run those tests. The nice thing, because we have several data scientists on our team, and I can think of at least one of them that had no idea how to do this. Again, this is not what they were trained in. So having the test catalog also helps them see how others have done it. So, oh wait, there's something called PS that I can use for this? So it helps collect that knowledge as well. Inference time on the operational platform, making sure that every inference is produced within a time frame. And this was the requirement that was specified was within 2 seconds was the output. Interpretability, understanding model results. So this is something, Super Mario, what is your name? I don't want to call you that anymore. So but he has a really cool shirt. I mean, I want it. And so so the interpretability has to do with the fact, and this is a requirement that you may discover later. Obviously, for this garden, there's also an educational aspect to it. And so what they wanted to make sure was that when a flower was identified, it would tell you why did it recognize it as a lilac? Why did it recognize it as a rose? So for example, it could say, I recognize it as a rose because it has thorns. But I bet that contributes to the educational experience. So now what happens is that a new requirement was placed on the model, because now it has to produce that, in addition to the inference, so in addition to saying it's a rose, it has to provide something so that can explain. In this case, the data scientist said, okay, I can easily do that with a heat map. So in addition to producing the inference, I'm also going to produce a heat map that shows which are the areas of the flower that contributed to this finding. So the one thing that I want to note here is that, as with normal software development, not all test cases are going to be quantitative. Some are going to be qualitative. So for example, modifiability is one of those quality attributes that is very qualitative. In this particular case, you are going to need, even though the test code itself can produce the heat maps for each of the flowers, a human has to be able to look at that and say, okay, yeah, this is reasonable. This is a reasonable heat map. So what MELT accounts for the fact that there are quantitative test cases, but there are also going to be qualitative test cases, and you have to keep that in mind as well. The other one was accuracy, 90%. This was what was defined. This is the one that you all know. Input and output specification, this basically means that the model has to be able to read the inputs and provide outputs according to the input and output specification. Input validation, in this case, if the data pipeline receives an input that doesn't conform to the input specification, what should be generated is the output N-A, not available or whatever, which the app will interpret as an error. So this is a part of an API negotiation that usually doesn't happen. And the data pipeline is going to create a log entry that says model-input validation error-whatever the input was. So now, again, the model has to produce an inference, has to produce a heat map, and has to log things. See, it's doing a lot of stuff, which if we don't have these conversations, we don't know this is needed. And so then you can actually check the log entries to see if that's being done. For monitorability, this is important, and especially with the pressure that was put on us to be able to generate repeat visits and continuous visits, new visits to the garden, it has to be able to detect things that make it fail. Like, for example, detecting out of distribution inputs as a form of drift. And so basically, the model has to be able to detect, or the system, some part of it has to be able to detect that out of distribution is happening. And this is on the output side. If the output is drifting, that it also has to be able to detect that and produce log entries for those things. And questions so far?
My question is about the context fields that all of those entries had. So all of them says normal operations. Can you provide examples of what can be other entries?
Yeah, so for example, it could be stress conditions. So for example, the model has to be able to produce results within 2 seconds, even when it's between 10 a.m. and 2 p.m. on a Saturday, which is when I know the most people are going to be here at the garden. I'm making it up. So in that case, it would be like under high load conditions. So high load would be a good example. Mm-hmm.
Thank you.
Mm-hmm.
Yeah, I have a question regarding the interpretability of models. I know this is something that is desired in almost every industry. But my question is that if models could tell us the kind of features that they base their predictions on, then do we need machine learning models in the first place? Because I believe that if they are able to tell us the kind of features that they are focusing their prediction entirely on, then we could sort of use simple rule-based systems to sort of, automatically engineer this and then use rule-based systems, because in that case, we will require less compute power to make this, happen. So is this something that can truly be achieved in the long term?
Yeah, so let me see if I understood your question correctly. So you're saying that it could be possible that if the, and I'm going to say system in a very broad sense, if the system detects that the model is no longer producing good results, it switches to like a backup model or a secondary model or a canary model or something along those lines. Is that what you said? Or
Yeah, I think that was gonna be my second question,
Oh.
but yeah, I think that
We're on the
yeah.
same.
If you prefer, you could answer that, and then I will reframe the question. That I
Okay, no,
just asked.
so I think the question is, do we start considering that at this moment? So right now, in this process, what we are discussing is the ML component requirements. So to me, what you just stated is a system level requirement. And so then what I need to do is say, okay, based on this system level requirement, what are the requirements for the ML component? And so, for example, you could say, maybe there's a specific type of output that it produces that triggers the monitor to do something. Does that answer that part? We really need to distinguish between the two, because obviously the model, this is like software architecture. Like, I wouldn't put all that responsibility on the component. That would be a bad architecture decision. But the system does impose some requirements over the ML component. Does that make sense?
Right.
Okay.
Yes.
Okay. And you said or did I answer both questions?
No, the first one was regarding interpretability of ML systems.
Yeah.
Yeah, and the question was that if it is something that we desire so much in almost every sector, and models could, explain the kind of features that they base their predictions on entirely, and it's something that can be, done to a very good extent, then do we need ML systems in the long run? Because if we know the kind of features that ML systems base their predictions on, then wouldn't it be much more reasonable to sort of use rule-based systems to, build these? Yeah, because in the long term, we wouldn't require as much compute power than we do.
Yeah. Well, I mean, this is, I think this goes back to, I don't even know what it goes back to, but I know we're all like really excited about machine learning, and now LLMs are like, it's funny because some of you have the questions that you've asked. I know that you have generative AI in your mind when you're asking them. And so now this has become like the answer to everything. And the first question that anybody should ask, and I think a good system architect and software architect is, do I really need machine learning to do this? Is it really necessary? And you had concerns about energy consumption. Yes, if I knew Chinese or Japanese, I'm not sure I would try to interpret that, because that would become your name. But I mean, energy consumption is, do we really want to do that if it can be simply solved with a rule-based system or with something else? Yeah. Okay.
I also had a question. You mentioned some of the cases where the data in some way gets corrupted to the input, or the output is corrupted. But I have a specific case in mind, and that's about basically unrecognizable by the machine learning because it was not tested on it, and it decides to hallucinate on it, to give something else. How would be a way to test that?
Right. So, yes, that's a very good question. But to me, Grace, that is why I define a machine learning component as the combination of the data pipeline and the trained model. Because, first of all, they need to work together. But they also need to be separate so that they're more reusable, et cetera, et cetera. So that is something that you could easily test in the data pipeline side. So for example, you could have, as part of your pipeline, there could be an input validation component that does all those checks. Does it contain ASCII characters between blah, blah, blah? Like, all that input could happen in your data pipeline. And then again, your test case in that case is simple, but because the requirement is exactly what you said. The model will only process valid inputs, but then you have to define what valid means, which goes to his question of what was blurry. And you define the valid inputs, and you make sure that, in fact, the data pipeline piece does that.
Okay, thank you.
Okay. So let me get to the MELT report before I'm getting to the end, and I think I still have plenty of time. So I was going to show you this demo, and I had to take an old screenshot. I'm sorry. I really wanted to show you the demo. But the MELT report, basically what it communicates is the test results. And it does so, you will recognize some of the quality attributes that we talked about because they're there. And it basically shows with green the test cases that passed, and it showed in red the test cases that failed. So with this type of information, now you can go back to your stakeholders and say, look, all these tests passed, but these two, they failed. Let's talk about how either we relax the requirement, or we do something different, or what can we do to make those pass? And ideally, at the end of many iterations, that will all be green. But yeah, so this is basically what the MELT report does. We're working on a lot of UI issues because I don't like this UI. But anyway, that's MELT. And so our hypothesis, position, some other noun, is that at the end, because you've followed this process, not only do you have a production-ready model that is going to meet all your system requirements, but you also have all the evidence that was produced in the form of test code, test data, and test results, that if your software engineers wanted to replicate this testing, they can do it. They can do it because everything is there, so they can do it themselves. They can test once it's integrated, et cetera, et cetera. So that is the advantage of following something like MELT. So another checkpoint. So I told you, or at least I tried to convince you, that because I'm using MELT, I am better at test and evaluation of machine learning components. I just want to see if you understood. So what are the concepts behind MELT that you believe are in fact leading to a better test and evaluation process for machine learning components?
Well, first of all is the measurability of things, to identify exactly the measurable metric that we want, and also the modularity, as you mentioned, the Jupyter notebooks, of ordering them.
Yes.
So that we can repeat it even afterwards and before the same tests, exactly.
Right, so the repeatability of test cases, the response and the response measure, which make them very testable. Yeah? Mm-hmm.
I want to also add the whole negotiations part,
The
right?
negotiation-
That the ML team is in all the context of the entire organization, not on its own.
Yep. Yeah, so the stakeholder negotiation piece and making sure that everybody's represented at the negotiation. Yes.
And the test cases should be as unambiguous as possible. Like they were actually as unambiguous, like they were really straightforward and this is what you need to meet. So
Right.
that was one thing which I observed.
Right, so very, very well specified requirements. Okay. Anything else?
Increasing communication within all the team members and everybody responsible for the system.
Yep. Yep. So everybody's working from the same set of requirements, the same assumptions. Yep. The same information. Yep. Okay. So, like I said before, we have a team at an AI organization that is using MELT. Here are some of the things that they have said, and I think it resonates a little bit with some of what you have said as well. So when we asked them, like, what do you like about MELT? What is good about using MELT? They said that it forced model developers trained as data scientists, because their developers are all data scientists, their model developers are all data scientists, to think beyond model performance, which is something that they had not done in the past. That it guides the requirement solicitation process, and therefore it identifies requirements beyond accuracy. It facilitates the development and reuse of test code for these requirements, so basically they appreciate the existence of the test catalog. It ensures that failures and inconsistencies in model performance are detected early in the process and not when things are already in production, which is something that they were seeing a lot, unfortunately. And it provides evidence of testing, which in their mind increase the trustworthiness of machine learning models. So this very similar to what all of you said. Other reported benefits that I think taking this approach, especially an approach based on quality attribute scenarios, not necessarily MELT, but just an approach based on quality attribute scenarios, is that it does enable communication. It does enable that communication between different stakeholders. It also, because of the information that is captured in the negotiation card, it provides better input for people making model design decisions. And also it starts enabling their reasoning about trade-offs. So the typical trade-off is, accuracy and resource consumption, right? It helps people start those conversations early in the development process. So what are we doing now? So one of the things that we're doing now, now I'm talking about the research that I'm doing right now. So like I said before, earlier, there are standards that have emerged specifically for AI-based systems, like ICE 25029 or 49. I can get you that information, but there is an ISO standard that is specifically targeted at AI-based systems that is based on 25010, which is a traditional one. And one of the things that we think is wrong about those standards, and most of them is that I don't think they're doing a very good distinction between system requirements and model requirements. They're doing a very lousy job at that, in my opinion. And so what we're doing is we're creating our own categorization of quality attributes and saying from an ML perspective or AI perspective, here are the quality attributes that might be important for a machine learning component, and this is how we categorize them. So we're building on our categorization, but it's basically because I think that the work that is out there unfortunately isn't separating between requirements at the system level and requirements at the ML component level. We're also working on, specifically in the context of MELT, improving the traceability between QA requirements and test code. So right now in MELT, the kind of like the test code is quite separate from the requirements themselves. Like it's very loose coupling between and so we want to make it a tighter coupling so that they're more traceable, where you can say this requirement is tested with this specific piece of test code. We're implementing many UI and process improvements based on user feedback. We're not UI people, and that's very clear when you see the tool. Future work, we are also, in next year, we're going to focus on extending the test catalog to also include data quality requirements, which is also very important, so testing the quality of the data. And we want to improve the test evidence that it produces. I mean, maybe test data, test code, test results is enough, but we are working with other organizations to see what are other things that would constitute good test evidence that would increase your trust in the model. And so, just to summarize, I think the message today is that ML-enabled systems are software systems. They are. ML components are software components. They are. In the end, it's a piece of code that is running somewhere. There are some differences from traditional components, and we talked about those earlier. Most software engineering principles and practices apply. There is no secret sauce there. I mean, they really do apply. Some things are different, and actually that is a lot of what we do, is try to identify these areas where they don't quite align. And some are going to need to be adapted to account for those differences. We really need to bring software engineering discipline to ML component activities because they are software components. So it's not a bad idea to, I know that most of you want to go to industry, but maybe those of you that might be considering a PhD or something like that, I think that a really cool area of work would be tools and practices to bring some of this discipline to data scientists because they just don't have it, especially in cases where machine learning teams are separate from software engineering teams. To summarize, development and testing of ML components, there are three things that it requires. It requires collaboration with ML-enabled system stakeholders. You talked about that, communication between everybody. It really requires a system-centric approach because if you don't, you wouldn't develop a traditional software components without requirements. So why are you doing with machine learning components? Again, no sense there. And it also requires using some of that software engineering discipline to testing some of these components. Yes, that is the logo for MELT. It wasn't me. See, MELT, melt, grilled cheese, melting. Got it? Okay. And actually, in the US, you would call that a melt, a grilled cheese sandwich. So, wasn't my idea. MELT, what I shared with you today, I mean, it's not the only process. It's not a finished process by any means. But what I wanted to get across today was, regardless of the process that you use, some of the elements that need to happen for testing and evaluation of machine learning components to be effective. All the tools and the references that I mentioned today, they're there. If you ever need to reach out to me, I'm happy to talk to you. That's my information, and I am going to be sharing my slides with Henry. I know you're posting them somewhere. And I think that's it. Thank you very much for your time. I can take questions.
Do we have any question?
Super
Yes.
Mario has a question. Do I need, I'll put my slides up in case I need to bring them back. He had a
May I
brief-
ask first? Hi. Okay, hi. Here. Yeah, right now that you just mentioned that, the future work extending regarding the quality of the data, at the beginning of the presentation, one of the challenges that I thought for testing ML components is that especially the data, when you generate test cases for a normal system, you don't usually require that much data, and the specificities of it, it's easier to replicate, right? Or
Yeah.
even synthesize it.
Mhm.
But for an ML component, a lot of the time the data requires of a lot of cleaning, processing, cataloging. Do you think that this framework in the long run would need to be extended to consider the data engineering and processing as a separate development phase?
Yeah, so actually, I think I heard like 3 different questions, so let me try to answer them by pieces. Is the data piece a different phase? I don't think it's necessarily a different phase, but you saw that I called out the train model and the data pipeline. To me, the data pipeline, again, has to be treated like a software component, and in fact, that is a traditional software component, or a set of components. So that is, I agree with this. It has to be considered as part of the ML component development, because the reality is that your data isn't going to come from the system as a feature vector. I mean, that's not how it comes. It comes as a employer record, or it comes as a picture, or it comes, so taking that and converting it into the output that the model needs, it is a software development activity, and it has to happen within ML component. Now, in large organizations, we worked with a bank in Pittsburgh. They actually had that divided between 2 teams. They had the data engineering team that was responsible for developing that data pipeline component, and they had their model developers, their data science team that developed the model. Surprisingly, they didn't talk to each other, which again, goes back to but they did have that separated into different teams. But I would say that when it came time to deployment, that became a single component. Does that make sense? Like, it became a single component. So is it a separate phase? I don't know necessarily a separate phase, but is it a different activity? Absolutely. And I think it's equally important. Now, the data quality, the reason that we want to start treating data quality also and start defining quality attribute scenarios as well is that have any of you used a tool, open source, that is called Great Expectations? Have you used it? Yes? You know what? You've used it. It's a great tool. It's a bunch of very standardized statistical tests that you would apply on data. Absolutely. Now, is the data set balanced? I mean, how much of the data is empty? How much of the data doesn't follow this specification? It's great for that, but the problem is that even if a data set passes all those tests, it is not a guarantee that it is enough to meet my requirements. Am I making sense? So that is why we're interested in data quality, and for people to start specifying those requirements, just like we specify quality attribute scenarios, saying like, from a data perspective, what expectations do we have of that data? Did I answer everything, or did I miss something? Okay.
No, yeah, thank you.
You're welcome.
So, okay, hi.
Hey.
Sorry, thank you for the great talk. So in your perspective, the ML is a component, or constitute a component. Have you considered ML as a stakeholder of the testing process?
Do you consider what?
ML as a stakeholder of
No. Okay, now that's interesting. Tell me why.
Okay, so maybe the next talk.
Oh,
I will
okay.
talk about that.
Then I'll wait. But
I
so
want to-
do you say it like in the sense that it also has its kind of like requirements and like it has its limitations as well, like the science in itself?
No, and what I mean is and maybe, I mean, everyone is afraid that it will take over the human beings' things, right? So the idea is, how would you incorporate or embrace this new stakeholder as a peer in a
I see.
testing process?
Okay, nice. Yeah, cool. Very cool.
Yes, my question was coming back to the very beginning, that as I understand was one of the rationale behind developing Melt in general. So my question is, so all those companies that you interviewed during the paper creation process, how are they actually dealing with this problem that Melt is solving currently? So like, what's the current state of affairs with this problem?
So I can only share certain, because of non-disclosure agreements, I can only share certain information. But so the bank that I talked about before, their challenge in banks is that every piece of software that they produce has to be evaluated by an independent quality assurance team. Like that is a requirement just from the banking industry because of the many things that could happen if a bank system fails. And so the challenge that they had was that their QA team, traditionally, the way independent QA teams work is that because they have to be independent, they say, here's my software component and here is the specification. And based on that specification, they write wonderful test cases. But here's my ML component, here's my specification. And so they had no idea how to test this. So for that bank, the way that Melt helps is with the quality attribute scenario process. Maybe they don't have a specification, but they do have these quality attribute requirements, which at least they can say, okay, at least what we wanted to do, it does do all those things. And because it produces the test case, they can take that test code, they can rerun it, they can modify it. Maybe they say, oh, they didn't test for this thing. There's a bad test here, let me modify this. And so in that way, it helps that organization. For AI2C, that's the Army AI Integration Center, they mostly develop computer vision algorithms that go on drones. I mean, that's basically what they do. And the problem that they were having is that at least in the US, Department of Defense, military organizations, when they test things, they have these events. And a whole bunch of money goes into these events because they're live events. Basically, they simulate conditions and all that stuff. And the problem that they were having is that repeatedly, these models would go into the field and they would fail. And that was costing them a lot of money because these events take a long time. So now what they're doing is, what it's helped them do is, let's think about all those things that could go wrong and think about what we want them to do. And so for them, what the benefit for them was more than the outputs, which was the benefit for the bank. For them, it's help me understand how you're going to use this model so that I can build a better model. Okay?
So basically, to generalize and oversimplify a bit, so some companies already had all those processes, but just in some fuzzy way, and some just didn't have them at all.
Right.
Okay,
Yes.
thank you.
Thank you very much again, Grace. So Grace is going to stay with us for the next days. So any other questions, she's around with us, okay? So now we move down, okay? There's the exhibition, the posters, so be ready, all the teams, okay? And at 5 p.m. we are back here for the last talk from Barbara Russo, okay? Thank you. Professor Barbara Russo. She's from Italy, but it's quite far away. I mean, it's quite a trip, okay? So I think it's one of the most complicated trip you can get from Italy to l'Aquila. So thank you again for coming. So she's professor in software engineering. She has been working a lot on formal verification, and recently also integrating machine learning and software engineering. And now I will leave her the time for her speech. So, and please, as you did before, if you have questions, I can tell from this side, it helps a lot. So don't be afraid just to raise the hand if you have questions. If you like. This also gives a little bit of, getting into more links and, stopping with the presentation. So don't be afraid if you have questions. Okay. Thanks, Barbara.
Thank you, Henry. So we start now. So I am a software engineer, that's true. And because of that, I was very curious to use AI. And so what you see here on my background is a generated picture that I generated myself with ChatGPT. And how did I ask ChatGPT to generate that picture? You can see the prompt there. The prompt says, please generate a picture. I'm very kind. Please is something that I need to use. That people have not seen, I want to surprise you, right? Not seen, on generative AI, which is the topic of this talk, or conversational models, which is again the topic of this talk, for code generation, and with focus on code and not on human. I had to specify that because ChatGPT wanted to put humans in the picture. I didn't want to. So this image doesn't have humans. And this is the result of that prompt. Code generation is for ChatGPT this. So this talk is about code generation, and we're going to go through a journey, let's say, a bit of journey, and just a bit of myself before, if you like. So my background is in pure mathematics. My PhD is in algebraic geometry, and I worked in pure mathematics for a while. Then I switched to software engineering, very disruptive switch, let's say. And now I want to combine the two views into one. So this is my goal, my perspective. So since 2002, I am a software engineer, and as Harry said, I live a bit on the border of Italy, very far from here. You can see where I am here, there on the top, and l'Aquila is in the middle. So it's a nice journey, though. Anyway, it was very comfortable anyway. So it's a bit distant, but not that distant from what you're doing here. It's very near, in fact. So this is myself. I tried to find a picture at that time that I express what I'm doing. So I decided to draw it myself with a pencil. So this is not generated. It's just to tell what I am, let's say. I like to mine data for software engineering problems. That's my idea. And to use tools, advanced tools, modern tools, the ones that nobody knows already, to do that. Okay, that was my idea. So this is what I also tell my students who I am. I'm the one in the middle, if you don't see it. Anyway, so we have a journey now that I would like to do with you on uncertainty. One of the first things that I learned when I became a software engineer is that everything is uncertain in software engineering. It's not like math, that you have hypotheses and you prove it, and that's fine. At the end of the day, if you are able to prove it, but you are very happy. In software engineering, even if you have some results, you are not sure. Yeah, it depends, as we have seen. Ray said it before, right? It depends. Our answer to everyone is it depends, which is not for the math people. So this is a journey on uncertainty. I will go through first generative AI. They might already know, of course, the concept of them. I will just pick some of them, just the ones I need. Then I move a bit on code generation. So how to generate code with AI. Then I move again to something different, which is try to solve something of generation by prompt. And so I use so-called prompt engineering, how to query an AI for the task I want. And then, in particular, software engineering tasks. And then, finally, I will go through another topic which is very relevant for me and I think not that explored, is how to use generative AI for code in my case, but in general, as an actor of any process we do. For example, software testing, not as a component, but as an actor. We have seen before that we need moderation out of the results of an AI. Who is going to evaluate the quality of the results? Just us as humans? Maybe not. Maybe again another AI. Okay, so this is what we are working now and what I will present at the end of this talk. So let's go, and then I already excuse myself that I don't go through all possible generative AI models, sorry for that. Just pick some of them as representative models, right? So what's generative AI first? So it's based on models which are called generative themselves. And the goal is to learn the underlying distribution of data. You know it, right? This training data or pre-training data. And the goal is to generate new examples, new samples that resemble the training data, the original training data. This is generative AI, the goal of it, okay? And this will be our goal of this talk. Generative AI uses different techniques. We have seen this morning some techniques like autoencoders, and then there are also other techniques very fascinating for who likes the math behind. And the math, not only the pure math, but also some kind of applied math. These are generative adversarial networks also. You might have heard about them, GAN. And then what we're focused on this talk is transformers. And I suppose you know transformers, what they are. But I will go briefly through them. So if you wanted to have an idea better idea of this, just I put for you like a reference, the 2023 reference, very recent reference, the overview of them for other reasons than ours, but is anyway interesting because it's just enough, the information in this paper is just enough to understand them and their differences. So autoencoders, they are very used. We have seen this, your colleague today, speaking about autoencoders for anomaly detection. Prediction. And so what their goal, I mean, any of these techniques have their, let's say, inner goal, but you can use them also for your goal, but you need to be prepared that maybe the performance is different from the one in which the model is being built for. So the goal for autoencoder is to remove noise and irrelevant information. And this is why it's relevant for anomaly detection, because you have this function that tells you what's the distance between the regular output, the one you want to have it without noise and irrelevant information, and the irregular one, and these ones. And this is called, this difference we have seen this morning, reconstruction error. When it's high, you have an anomaly, right? So how they are, we have seen this morning, they are encoder-decoder. So they compress into a smaller vector space or probabilistic space, okay, smaller dimension. Why smaller? Because you want to remove the noise, the irrelevant information, and then repristinate it into our original one, right? This is what you know already. And so the idea is like you see here, you can have a noisy input that can be reconstructed. So these are two components, let's say, encoder and decoder. They help to remove the noise or the irrelevant information. As I said, I was very fascinated by GAN. GAN are networks that combine different networks plus an optimization technique at the end. So what are they for? To identify fake samples from real ones, to learn them, to distinguish them. In order to do that, they first use a generator. So generator, you see the first neural network you see there, to generate what? Fake samples. Because maybe you don't have them, right? So you need to generate synthetic data for that. And then after it, you have a discriminator that distinguishes between the real that you input and the fake that you have generated, and this is able to learn the difference between the two. Okay, that's fine. But then, okay, now we remember there is something called optimization theory. The optimization theory takes two functions. It try to find like a compromise, a trade-off between these two functions to get a best equilibrium between the two functions. So at the end of these GAN networks, we have an optimization layer. What it does, it takes the two loss functions of the generator and discriminator and optimize them in order to get the best output, the Nash equilibrium, okay, for them too. Right, so the better ability to generate fake data for the first, and the better ability for the second to distinguish fake from real. Trade-off between the two things. And that's GAN, and that's very interesting. So interesting for what? Assume that you have anomalies used with the encoders, then you wanted to distinguish the false positives among them. Maybe you can do this. You can use GAN for that. Okay, not our goal here, but just to tell the use. Okay, so as I said, there are these three components you can see here. So I find this very nice because it's a combination of techniques we have seen for when we do neural networks, right? And optimization theory. So in summary, we have, I didn't speak about transformer yet, I will speak now. So we have encoder, autoencoder GAN, and we have these transformers. Everyone speaks about transformers. Let's see what they are for. In particular, for us, is important what you see in the bottom. Code generation. They're used for that, mainly. Okay? Even computer vision generation, okay. So before going to the transformers, let's speak about the models, okay? Oops, I think I'm not the first one. So we're seeing the techniques. Beyond the techniques, there are different models. Models instances, I mean, right? So in particular, we use the so-called large language models. You already know it. What are there are just models pre-trained on large data sets. Typically, you might imagine the ones we have used already. Okay, so English text, okay, large English text. So in 2018, we know there will be BERT. I mean, at that time, BERT was one of the first bidirectional encoder representation from Transformer by Google. And then we have GPT from OpenAI. So these are the two, let's say, ancestors, if you want, the public ancestors, at least we want. These are large language models. Since then, maybe you like to read this nice paper of Yang in 2024 that reviewed the models, the transformers, but also not only the transformers, on the very left side, the one you are not able to read, I suppose, the gray ones on the bottom that finishes with 2019 are the ones rule-based, okay? So non-learning models. But the others are all learners, okay? The pink ones are the decoder only. Then there are the coder encoder, the green, and then there are the decoder only, which is the gray branch, which is the biggest for us. And I put on the top of each of these branches, the learners branches, the major goal they have. So understand, translate, and, as in our case, generation. And you can see how many models in the generation part are there. I also included something, because it's pretty new, was like out after this paper has been published, which is, of course, DeepSeek, okay, in the generation branch. We have seen before, in the previous presentation, there are several issues with AI, and of course, with generative AI as well. Okay, I just put 3 of them here because I found them interesting and relevant, maybe, but there are many others you have seen already, so I will not insist on that. First of all, I don't know whether it's a bad thing or a good thing, the generative AI models, they exhibit emergent behavior. So this means that they produce output which is not seen in the original data. Is it good or bad? What do you think? If prediction is the goal, yes. If generation is the goal, I don't know. What do you think? Sorry? Okay, you say mutation of maybe, yeah.
Yeah, it resembles like a mutation. The behavior is emergent. It wasn't predictable, but if the result is actually aligned with what we want, then it could be good. Like.
Yes, that's another important. We have seen, for example, one of the characteristics of ML-based systems is fairness. I also work on fairness as well. So if you generate data which are not corresponding to the data you wanted to use for your model, that's a bad thing, right? But I see also a positive thing in the sense I generate something that is not there. I didn't even think about that. Why not? Maybe an anomaly? Good. Maybe it's real anomaly. It's a good thing to have, right, to know. So since systems are evolving, understanding whether there are some emergent behavior that we didn't capture with a static data representation would be good also. So we are software engineers, we need to see evolutions. Another important thing that this goes back to this is the quality of what we get. Human beings do not agree on the quality of what you get. And we're going to see some examples now, and you will not agree as well. I assume we are human beings, of course. So another thing I like so much, and there is an article in IEEE Spectrum from which I take the example afterwards, is the term hallucination. We believe AI. We do believe the answers. And if I have short time, I need to produce something for tomorrow, I believe it. I don't question. Okay? And that's the problem. So, I just want to go back. So what is an hallucination is AI can generate incorrect and fabricated information, maybe emergent, that appears plausible. This is a problem. AI is verbose when it answers, and is convincing when it answers, right? If you are not able, if you don't know how to query it. And the problem, you believe it. And these are the hallucination problems. So what are the hallucinations? You say, no, but I'm an expert. I'm a developer. I know what's the answer. I know if it's wrong or right. Let's see this example. Oh, I need to go back here. So the scenario is this. I wanted to use a Ruby library for encryption. It's called AES, GEM. Okay, it's a library. And I query ChatGPT in this case to tell me how to use it for encryption. Okay, simply that. One simple, you see, very synthetic query. This is the query. The black thing is called prompt or query. Okay, so I just I just chat with the ChatGPT and ask this. Okay, with no preamble, no context, anything, just synthetically that. And ChatGPT is very good. It's very verbose and provides me with the code. Very good. How to use the library, I copy and paste, use it. Okay? How to, and also is authoritative and says, oh, sorry. I was like, oops, here. Authoritative say, careful, if you use this library with the default encryption mode, you can run into a vulnerability problem. So be careful to use it. Oh, very good. But then, it produces a code with a key for encryption. The key is 1, 2, 3, 4, 5. That is in hexadecimal is 0. The library uses hexadecimal conversion. So that's an hallucination. And you copy and paste it and use it. Very simple. Students do it. Okay? So this is an hallucination. Why is it hallucination? Because the result, the code works. If you run it, it works. No problem. the problem is not secure. And the goal that you asked for was to use a library for security. Okay, so these are the problems, maybe from the perspective of a software engineer that works with the code mainly, right? So low-level software engineer. So let's consider now that we want to generate code. This is what the students want to do all the time these days, right? My next lecture next week will be how to generate code for testing, instead of telling students how to test. It's a bit of disruptive change, but it's needed. Anyway, we need to understand what's code generation ourselves before teaching the students, of course. So just rephrasing what we've seen before, what's the goal for a generative AI? Code generation is a model that learns underlying distribution of code data. So this large training set will be code instances. And the goal is to generate new samples that resemble the original training data. Okay? So we don't want to create something new, in fact, in generation. So what we're going to use now is our decoders. You remember the branch on the very right? And we use the generative pre-trained transformer. Pre-trained means that they are based on large language models that are trained on large data set of code instances, okay? For example, GitHub projects. What we do normally with these pre-trained models, pre-trained models means they have their weights computed on the data, though, on the large data that you've used originally, right? Unfortunately, many of these data sets are not accessible for us, so we don't know really what's inside the pre-trained data set. This is our problem as well, right? They say GitHub projects, they say CoSearchNet, but we don't know how much of this or the other has been used. What we do, we take these models, they have their values done, right, in the pre-trained data, and we fine-tune for our tasks. Generate test code, for example. I take a general natural language model that is being pre-trained on English text, for example, or on code in GitHub, and I ask to generate test code specific to what I want, like my students next week, okay? And this is called fine-tuning. So this means that you provide another data set for the specific task you want to. Typically it's smaller because you don't have that resources to create the data set and to execute on that data set the model. And what it does, it just transfers the knowledge. Imagine it's a person. You transfer the knowledge from the pre-trained model to the fine-tuned models by overwriting the weights. So the idea behind fine-tune is don't start from scratch. Start from a model that has been already pre-trained, so the weights are already there. This is one of the biggest problems when you wanted to do any automation with computers. So you need to start with something that has some plausible values, let's say, and from that you can get your model for your task. And this is what is fine-tuning. In the past, when you want to use, for example, this application to derive a function by steps or to run some regression analysis, then always the problem was from which value do we start? If you start from very far, mathematically you don't reach the point you want to. And this is something similar. We need to start from something which has plausible values. And this is a pre-trained model. Okay, yeah, and we transfer the knowledge. With fine-tuning, we have problems again. We have challenges, let's call this way. Performance. When you have a very different data set than the original one in terms of the semantic, for example, you use a text pre-trained model for code generation, for code, the performance is not that good. Okay, and also the fact that the data set that you own, is smaller, is not that good as well. The performance might not be good. Might be good, it depends. but it's not for sure. The other thing is, okay, let's tune when the model has billions of parameters. Resources, that's a problem as well. Even though DeepSeek says that, okay, DeepSeek has 671 billion parameters, but they claim, and we don't know it yet, that they claim that for each token they just activate 37 billions. Okay, this is possible for us at least, right? Better than the others. And then there is another thing that I like so much. It's about information. Catastrophic forgetting. Do you remember when we said that fine-tuning means overwriting the parameters of a model? That's my lead to catastrophic forgetting. A model that learns to be something with a pre-trained data set forgets when you retrain on something else. It might forget, of course, not all the time, but it might. That's called catastrophic forgetting. Okay, so, sorry, I have, all these uncertainties are like coming with us in our journey, right? We try to do better, we are engineers, we try to do better and better. So we have so many challenges. Let's try another way, another path. Prompt engineering. Prompt engineering, who knows what prompt engineering is? Okay, so I pick one person, just down there. Can you just go there with the microphone and ask what's prompt engineering? Is Shuri, is very, very far. Is it she? I think. There, yes. You raise your hand, right? If you want, I mean. Oops, my God. One person, okay. I thought it was, okay, it's, sorry.
So basically, when you use or more like instruct an LLM to modify the way you ask for a specific task to actually get the output in a more task-specific way. So it's more on tweaking on how to generate more outputs.
The right term is tweaking, yes. I call it as an art, but tweaking is fine. Yes. Yeah, I think she's the one also that rises her. Yeah, what's for you? Is the same?
Well, prompt engineering can be said to be how to make efficiently make the model to give you what you want.
Yeah, that's the goal of it. Yes, that's true. Since it's an engineering, it means there should be kind of rigorous pattern for that, or technique for that, right? I'm trying to introduce it. I will not be exhaustive here. There's a paper, very nice paper surveying this, and I have the reference in the slides, then you can read it. It's really nice to read it. Anyway, yes, so prompt engineering does not need fine-tuning, but it needs something different, of course. You know, as engineers, we know that if there is an uncertainty somewhere, if there is a challenge, the challenge doesn't solve, just move farther, right, to another problem. So prompt-based learning is to instruct the machine, so the AI, generative AI for us, to do the task without fine-tuning. It does need not the fine-tuning. So what we do now is to understand how to instruct the machine. Now there is plenty of new techniques we can do it. This is a prompt example. So I just read it. This is for my students next week. You are a tester and need to develop an acceptance test from user stories. You know what's a user story? I think you mentioned, someone of you mentioned that. User story is nothing else than an atomic description of a functionality, a textual description, and you can see in an example soon, right? An acceptance test, you know what it is? Acceptance test, yes, thank you, one person knows it, is a test on this description, specifying the input and the expected behavior according to what the user story says. There is also a technique to derive it from user story, you just underline the names. There is a technique. I don't want to enter to it. Manually, human beings are unable to do it. And there is a technique for that. So it's the very first form of testing of a functionality without even having the code there. You test the functionality as a text, okay? Looking at the input, output, and expected behavior. So then I say the machine, you are a tester, so this is specifying the role of the machine in this interaction. You are a tester, you're not a developer, you are a tester. I give you the user story, you produce the test, okay? And this is, in fact, this pattern is called persona because it specifies the role. So then I say what I want as an output. I will pass to you a user story, and you will provide the corresponding acceptance test. I tell you how and what I want. Not how the machine reasons on that, but just what I want and how you do it. What you take as an input and what you give me as an output. And then I also say something more, and this is called chain of thoughts. I tell the machine to do it step by step. My choice. I want a step-by-step answer. How the machine reasons. By the way, if you have seen ChatGPT and DeepSeek, now they have a reasoner on the bottom that you can see the steps of the reasoning of the machine. This is an example of prompt. It's a text that I pass to ChatGPT, just in the text box, to get what I want. That's an example of prompt. There are different ways to do it. Let's start first to distinguish two ways. One is called few-shot learning, means that I instruct the machine by demonstrations. So I give examples. Instead of saying, not only saying what to do, but also to give an example of what to do. Okay? And the other is called zero-shot learning, and you imagine what is with no examples, no demonstrations. Okay? I just make an example, it's not mine, it's from the paper you see before. So here, you see, is a question and answer task. So you see on the top there is a few shot. So the thing you might see in green, so the first question and answer, is the example I give the machine. And then I ask a question, which is the black one, just after the first answer. Okay? And then I ask for an answer. Just a semicolon, okay? Column, sorry. And then the answer is given because the machine has reasoned on the example. Okay, and the question I gave, of course. The second case is without demonstration. It's just a question and instruct the machine to give me an answer. An answer should be in Arabic numericals. Okay, I can specify the format of the output. That's fine. And the machine gives me an answer. If I add to this a chain of thought, means that I ask to do things by reasonings. And for us, I was born in the agile development, so I reason by iteration, interaction, steps, and so on. I don't reason in waterfall way. So for me, the chain of thoughts is magic, because it gives me also the steps of the reasoning or the steps of the result itself, of the answer itself. Okay, so this is a new version you see on the right, on your left side. Here, you see, now I've added step-by-step by demonstration or zero-shot case. In the step-by-step, I just create my example, the answer, which is step-by-step, is structured, the answer. You see the difference with the other one? The answer is 11, there. Here instead, I give an example which describes all possible cases. So the machine is instructed to be step-by-step. Or, in the zero shot, I just say, I want step-by-step, the answer. So either you go by demonstration, or you go just telling the machine, you can add this step-by-step procedure, which is more illuminating than just getting an answer, which is a kind of black box. So chain of thought for us is important to use in the prompt, at least in the software engineering tasks. Okay? Okay, let's make this example. And I try here because I've done it for the students, so let's see if it works. So in software testing, we have seen testing today in terms of architecture, of course. Now we're going to see in terms of code. Okay, testing the code. So prompt engineering is a way to build interactions, so a new form of, let's say, collaboration within a process with an AI. So we are building not only this prompt, these templates, but we're building the way we interact with the machine. So the machine becomes an actor, a developer, a tester, a maintainer, an analyst, a designer. It can be anything, because anything is based on text anyway. We can conversate with the machine. So it's a new form of interactions we need to build and to model. So I asked the ChatGPT to generate acceptance tests from user stories. And I passed this prompt. Now it's a bit more detailed. But it's not detailed by chance. It's detailed because there is a template behind. Okay, so here I say that the machine is a tester and need to develop acceptance tests from user stories as before. Let's take a step-by-step approach, chain of thought. This is a without demonstration, it's zero-shot chain of thought. And then I say in each step I pass you this input, I want to get this output, I want to have it in this kind of format, MD file, because I want to upload in my GitLab repository soon. Okay, and I also give the MD representation output, like the layout that I want for my output. So I want to have a test case ID, an input description, a description of how to test this for this input, and the expected behavior. Maybe you have seen something like that in the courses, right? This is what we do when we test since the beginning. We want to have this information in this way. And then I pass the user story. Now I read it. This user story is an auction function, and a functionality for an auction system. I make a bid. So this user story is about a bid price, how to bid, okay? And so the bid price, a specific format, has to be the new bid price, the current price plus a multiple of a specific increment. This is written there. This is the instruction, it's a functionality, I want this way, okay? It's a verbose, it's a text, and it passes everything to the machine. Let's see what the machine does. DeepSeek. DeepSeek provides with the right template after a while. Anyway, different test cases. What do you see in these cases? Each row is a test case. So this means that each row will test the functionality to bid with different input values. Do you see anything weird? Sorry? The current price is always the same. That's true. It's not really bad, but the fact is the input in general doesn't provide soon the values, but the input in general in a test, acceptance test, describes the input. So for the valid case, for the invalid case, here you can see there are like the valid bid, the first one, there is the invalid bid, price too low. Then there is another invalid bid, which is action is not found. There is no action, so why you're bidding, right? Invalid bid action not started. The action is there, but is not started yet. So invalid bid action is ended, it's closed. And there is another invalid bid, incorrect bid calculation. I fooled the machine because there is a redundant case here. This one is fooling the machine. My text, and if you use reasoning in DeepSeek, you can see how the machine works. Reason is fooling. The machine here provides a bid, which is not a current price plus the multiple of the increment, but just lower to some given price, which is not even there. The machine is being fooled. Why? Just simply because if it goes back, it doesn't want to go back. I don't know why. Here it is.
I had the audacity to write 2 sentences about the price. One is telling what the price is, how the price is formed, calculated, and the second one is said, if the price is smaller than the expected one, but this doesn't mean it doesn't have to follow the calculation that I tell the machine to use. Instead, it did. So it considered 2 cases. It doesn't distinguish, so it doesn't reason on combining the 2 things and provide me with an extra case, which a human being will never do. Okay? In addition to that, it also uses, it doesn't consider edge cases, null values that we use to do it, right, by default. Okay, let's go ChatGPT. ChatGPT instead provides an input which is descriptive, tells what the input is, which is better for the acceptance test, is the standard. It should be this way. Unfortunately, the ID of the test case is not a good standard because students take this ID and write a method with that ID. So they create like tons of methods for each of these input values, each class, let's say, right? And so this is very bad. This drives the students or the developer to write too many test methods. Instead, you need to group them by semantic, okay? And don't call the method like add bid, test, valid bid, which is wrong as a standard, okay? So this drives some incorrect future development. One thing. And there is another interesting thing, more subtle. This case says that's invalid price bid because it's not a multiple of a bid increment. It's not correct. It should be a current price plus a multiple of a bid increment. So in an auction, you bid on the current price plus something which is fixed. This is called increment. Okay. This is wrong. It's a wrong input description. Again, no edge and default cases, and this convention of the test case. So, and I was so clear in my prompt. I gave the machine everything. That's the problem. Again, the uncertainty at the beginning. We have a challenge here. Prompt engineering is a mixture between an art and a formal representation of a text. You need to be expert. So the point is also what we have seen today. Without our monitoring, the machine gets fooled. Okay? Even though we are very accurate sometimes. So we need to try and try and try. So prompt engineering does this. As you already said, prompt engineering wants to do that. Okay. Let's make it formal though. That's prompt engineering. This is a nice paper, so you read it if you wanted to know how prompt engineering works. These are the building blocks. They're not so difficult at the end, just let's read them. So we have an input, for example, a text like, I love this movie, okay? And we have an output we want to get, which is, for example, a judgment on the movie. Positive, so plus, plus, very positive. That's a label, okay? We want the machine to respond with a label. We want the machine to generate a piece of code, okay? Same thing. So there is a function which is called prompting function. What it does, it creates the template where to put the input and the answer in this interaction with the machine. So you see here, X is a slot where you will put the input, and Z is the slot where you will put the answer of the machine after you instruct it. In between, there is some text, like the one I've written before, right, for the user story acceptance test. Some text that help instruct the machine. So mathematically, what you do, you have this function. You first of all evaluate the function on your input, and you can see it here. Where is it? The prompt is nothing else than the evaluation of the function on that input. I just put, instead of the X slot, the input, I love the movie. That's a prompt. The one I've written before, it was a prompt as well. What I leave unwritten is the answer. The slot is still there, the Z slot. Then there are some terminology. If I fill the prompt with some Z value, I call it filled prompt. If I fill the prompt with a true answer, it's called answered prompt. Okay, that's just definition. But then I have a set of possible answers. Can be the whole vocabulary, the whole code, okay, or a subset. Like in this case, it's just 3 answers, okay? Good, fantastic, and boring. And what I do, I search within this space. The machine searches for the best answer within that space you gave to it. So you need to define a space in which the machine needs to search for the answers, and then you need to fill each answer into the prompt for the Z slot and ask the machine to get the best score. So the search within a space is nothing else than searching among all possible answers the one that gets the best performance of the model, which is the probability you can see there. So I simply use a simple model performance score to get the best answer. And that's my answer. The answer is the one I fill in my prompt. Then I need to go back to the data set and see which one of the values get my score. And that's my final output, the label I search, for example, or the code I want to generate. That's prompt engineering. So it's not simply, I think it's better writing this way. You have a template to follow, and there are people working on templates for software engineering tasks. And I'm going to show you some here. And in addition, there is some math behind it. It's not simply a random answer because you prompt it. It's based on probability that that model will give you a higher score for that answer. So let's go back to our Gen AI for code. And what I want to sell here now is this. Gen AI for code is a stakeholder of the software development process. In this case, the example I'll give you is for testing, but we have kind of built a process with the generative AI as an actor, not as a component, not only as a component, let's say, for us as an actor. And we use prompt engineering for that, to define the interaction with this actor. So there are some open questions we want to answer. How can we integrate generative AI in software development, not as a component, but as an actor? How can we interact with the machine, so defining interactions modes? How can we control for the quality of the output? That's another big point, right, for the generated code. So you see, the machine is an actor, but generates something. It produces a product, so it's both. It's like a developer. It's like us. It reasons and gives you an output. And this is what you need for the product, right? Then there is a problem of localization of the output, and as we have seen before, it's not a system result, it's a piece of code result. That's another problem. So what we want to propose as a startling solution is embrace generative AI for code as a stakeholder of development process. And then we want to design model of interactions between humans or machines for doing that, for actors of the development process. And we want to design these prompts, knowing how prompt engineering works. We are not the ones who started this. There is this nice paper that produces a catalog of prompts for different tasks, software engineering tasks, and requirements, elicitation, system design, simulation, code quality, refactoring. There is nothing for testing. And then we enter it, and we did it for testing. We have started. So we wanted to create templates, also prompt templates for testing. So you can write this paper about this catalog of prompt patterns and our paper for the testing parts. So what we did, what we know now is there is some rigorous mathematical approach that helps me to interact with a machine. To do what? Generate code for me. Can be generate tests, other cases. Code, test code. From what? From text. And also, I pass a text, I want a code. I pass a user story, I want a code. So the new paradigm now is that the developer doesn't disappear, but simply doesn't do the straightforward things like generating code that everyone knows how to do it. So I give you the functionality and the machine gives me a code. Why not? The problem is we need to control what is the output. But there is a very formal process to do it. We need to learn as developers, software engineers, how to prompt machine. We need to know prompt engineering, okay? So let's look at this case study we ran with 16 people, 6 professionals. So we have a specific practice of testing which is called test-driven development. Who knows it? I'm scared. Okay, thank you. 3, okay, good. What is that? I just anticipated because we don't have much time, but test-driven development is a development practice. It's not a testing practice, in fact, because you write the code because you have written the test. How you do it? But you use something that is already there, the compiler and the virtual machine. The compiler will tell you whether the code exists already when you wrote the test. The virtual machine tells you whether the code executes correctly. Otherwise, you need to test more, and you write more tests first, and then you code. I will show you an example. This kind of development practice is nice because it's iterative, it's interactive, we can define roles, testers and developers, and it's incremental, very difficult for the machines. Because the AI machine, the Gen AI machine, they tend to provide you the solution one shot, not by step. We need to use chain of thoughts to do it. And once we discover it, that was magic. But before, just get the whole solution soon. It's not incremental. It doesn't represent the process. We want to model the process with the interaction with the machine, not the product only. And the process is very hard to represent. So thanks to chain of thoughts, we're able to be incremental at least. Okay, this is it. So this is, you can read the book of Ken Beck on what's test-driven development. I just summarize it here. Sorry if I'm not very exhaustive. So what you do is, in practice, you write a failing test first, an assertion that fails. First, you don't write code, just that. Assert true, f(x) = 1, whatever, and x is 3. That's an assertion that fails. By intention you do it. Why you do it? Because you want the compiler to understand if there are types around. If you have specified the types. If not, you need to write the code for the types. Easy peasy, right? Then you write just enough code so that the test passes, and you write another test. And you go on. And we use this approach not for tests, but assertion first means that we go by assertions, not by test methods. At the end, there is also the possibility to refactor the code. And here is the point. Who refactors it? Okay. This is for future, by the way. So this is, you see here, a workflow example of how this TDD works. And this is an example I always use with the students. So I want to center a word in a line. So and there is a method called center that centers a word in a line. So what I do, I first create my type in the test method, which is called test center line, and the type is called formatter. I instantiate it, and what happens? The compiler says, are you fool? There is no formatter type. And I write it. I write the class, formatter. I write a dumb class, as tab is called, right? With nothing in it, but just to satisfy the compiler a response. If the compiler sees the formatter there, it works, it's happy, and it gives you a pass for the compiler. Since I just wrote like a method with just an instantiation, there is nothing to do. So only when I write the formatter, so on here you see the test code, on your right is the code, the production code, right? So I just write just that piece of code so that the test passes, okay? And here passes. But that doesn't do anything, right? So that's a problem. So then I start to write some assertion. And you see on the top there, assert equal, the word needs to be centered in a line of 10 characters. And then I call a function f.center word. This function should center my word in 10 characters. I just write the assertion. I don't write the code, just the assertion. Of course, the assertion fails because there is no function f. No function center. So I need to write the function. And this is the way you do it. So write a piece of test so that the compiler or the execution machine falls, and then you write the code. Stepwise, here and there, okay? This is what I want the generative AI to do. And so this is the final solution when finally I get the right code. Okay, is it iterative, incremental, and allows you to think really to the logic in steps, like I want the machine to do. Okay, so it doesn't want to go on, so I don't know why. Okay, I just jumped one slide, that's not a problem. So for this experiment we have done, we used ChatGPT. ChatGPT, you know what stands for, I just don't want it to go on, but anyway, is one of our favorite transformers, right? At least students' favorite transformers. So what we did is, first of all, we wanted to reconstruct the workflow you have seen before at the TDD, test-driven development process, into a workflow that can incorporate the generative AI as an actor. In this first workflow, you can see where there is the green AI symbol. That's the machine that works. The others are the humans. This is one possible scenario where we call one agent because the human is a tester and the machine is the developer, answers with the code, okay? So this is the interaction we have. We still keep the human in the loop as a tester, and the machine is the coder. The second scenario is full automated. Machine does everything. The generative AI does the test and the code, both. And this is the new workflow. What is new here is the input type. You see, what we feed the machine with is not simply with the text, but with the information we get from the previous interaction, which is the error stack, the code already generated, and the test generated. So this is our input in this case. Here it is. This is our new prompts that we have created. Maybe I highlighted with the red boxes the places for the input, the slots for the input we have. You have several different templates we use, and we were successful to use with our assisting practitioners. Okay, so I don't want to just go through, but you can read what they are. But the interesting part of this is our prompt is not simply a number. So our prompt doesn't simply contain a text or a number, but contains the information generated from the previous iteration with the machine. So what is relevant for us means errors trace, code and test generated before, so that I can instruct the machine to do the next step. Okay, so it doesn't want to go when there is an image. Okay, let me just try to do this and go back. Yeah, so the experiment was not with students, but with professionals intentionally, because we wanted to know whether the professional got crazy with this new paradigm. So we used the same functionality, center a word into a line, and we asked them in 40 minutes to produce the code and the test code with TDD. We use, for ChatGPT, we use GPT 3.5 Turbo as a model. We use API for querying automatically, let's say, especially for two agents automated case. We use Python as a language and use Google Colab to collaborate at distance with them. So I just jumped to the conclusion what we got. First of all, it's not a surprise to me, but it might be a surprise. The test, so the code we got as a test, is better, more organized, semantically organized when you have one agent case. So when you have a human as a tester and the machine as a coder, as a developer. The fully automated one, as we have seen in the cases for the bid, for the auction system, it's creating lots of redundant cases, many times not grouped together, right? With the things we have seen before, some problems, there is no edge case, no default cases, no null cases, and so on. Better though, also, with a baseline. What's the baseline? We ask some participants not to use AI at all, to do it in a traditional way. No edge cases, many other things were forgotten. So, it's not bad to have the Gen AI into the process. It's important to have a process that really embeds it into it, so consider how to interact with it. So we need to use prompt engineering, we need to define the workflow, how to use the machine in different phases correctly, and how to instruct with chain of thoughts, and possibly demonstration, but also not, to go step by step, because our way to develop is incremental. Our human way to develop is incremental, iterative, and collaborative, right? So if people say we need to, developers will never have a job in the future, it's not true. Collaboration is the future. Monitoring of the quality of what you get, even with a very nice prompt, is the future. And a new paradigm for development, embracing generative AI as a component, but as an actor, is the new way to develop things. Okay, system, software, whatever. Finally, sorry I killed you, I suppose, because it's late, but I'm enthusiastic in this thing, so we're working with generative AI so this is everything for what I want to say, the message I want to say. We are working with generative AI in many other ways, because it's a very powerful tool, but the important thing is you need to know more than the generative AI if you want to have quality results. And this is what I'm going to say next week to the students too. But Gen AI is very good to also to generate, to support developers. For example, generate code comments when there are none. And these comments can be on so-called technical debt, so not very good code, or insecure code, weak code. So you can warn developers by generating documentation for them saying, look, that function is insecure, has a key which is 1, 2, 3, 5, which is converting into 0 in hexadecimal. So we can do something also for developers with Gen AI. So generating comments, generating code and comments, generating vulnerable function to detect them. This is what we do. Predict technical that predict vulnerable function. Another thing that a student of mine, a PhD student of mine, is doing now is take an attack text from a magazine, so a news. Tell me which vulnerability will be in your system. This is just simply an LP problem, because you can go to these big repositories of known vulnerabilities, the MITRE one, and you can eventually associate to a text, let's say, a list of possible vulnerability. You can generate a vulnerability text to tell the owner of a system, look, you have this in-house, but soon, because the problem with security is the zero, what's the name? The zero time, no, it's not zero, now I'm tired. Sorry? Zero shot defects, the ones that the owner of a system doesn't know to have, but the attacker knows it. Okay? And being able from a simple news of a newspaper about an attack, telling, oh, these are the vulnerabilities that are known, it's helping people for security. 0 day attack okay? When the attacker knows your vulnerability, but you don't know it, neither the vendor. So this is useful to react soon to the incident before this causes some damages in the computer system. Okay, so I think this is what my group is doing, not myself only, right? And just push them to this direction because I find this opportunity for all of us really important to embrace, not to contrast, right? That's very important for me. Okay, that's all. If you have questions, oh, maybe I wanted to go through.
I have a question regarding the takeaway from the lecture. So you said that it's important to see generative AI as an actor that collaborates with the human to produce program code. But the idea is that you presented this idea of generative AI actor that writes tests, right, and programmer writes code, right? But that brought me to the idea, why not to consider theoretically that the human is a conductor that orchestrates different generative AIs that do different things. One writes tests, another writes actual code, third writes documentation, and so on. What do you think about that as a perspective for the future?
That's okay. In this, you're right. In this example, I gave a peer contribution between a human and an AI because this is what I wanted to make sure that you are not afraid of embracing this. But I just wrote a project on how to orchestrate, in fact, the generation over a development process, and that's a human orchestrator in my point of view, because as a quality manager, so even the developer needs to know more than the AI to be able to see whether the output is an hallucination or not. Yes, that's for sure a big role that the developer will have in the future. And for prompt engineering is a way to interact, in fact, peer-wise.
Okay. Thank you.
More question.
You mentioned earlier about catastrophic forgetting. It might not have been the main topic of the session, of the presentation, but can you expand more on catastrophic forgetting and how we can avoid it in a LLM? Or the catastrophic forgetting.
Catastrophic forgetting. Catastrophic forgetting is related to fine-tuning. Okay, so it's related to fine-tuning. So what we use here is not fine-tuning at the end, right? We use prompt engineering with a pre-trained model without fine-tuning.
Yes.
So there will be, in principle, no catastrophic forgetting, okay? Maybe misleading of the instructions, yes, but instruction we give in the conversation, but there is no fine-tuning. So we don't overwrite the weights of the pre-trained model. We don't do it in the last part. Catastrophic forgetting means that you have a very nice, very high-performing model on a pre-trained data set, which is not yours, is someone else that you don't even know what it is, that provides a model with the values for the weights. So it's perfect, right? But then if you move it to, if you want to use it as is on your data set, maybe it's not so performing. I don't know, we need to use prompt engineering for that. But if you fine-tune, it might be that since you overwrite, so you overwrite the values of the weights, these are not representing anymore the learning, the knowledge that the machine had before. And this, everything is lost. Your pre-training is lost. And the machine does something which is not, let's say, related to the knowledge that they got with the pre-training. So if a machine is able to translate from French to English with a big data set, an LLM machine that is being pre-trained for this, okay, and then you do it for another language, you might do it, try to do it, because our characters, in fact, but maybe the machine forgets. I have a slide, but maybe it's too late. with the catastrophic forgetting, as you can see. Another thing that I didn't mention, and that's very interesting, and it's up to you to work in the new future, because it's your world that will change. If you use the machine over and over on the same instruction, so you have a text, and you from the text you generate another text as an answer, okay? You take this answer and you generate again, and again, and again. What you get at the bottom after 8 iterations, I think, something completely detached. So if the word in the future will be generated, maybe it will be a crazy word, because it's detached from the original. It doesn't have the same semantic. I think I'm healing things as the other speakers. So there is a nice paper saying that after 8 regeneration of the text, you lose connection with the original data. So this is another important point. Can we live in a generated world? Because now I generate the code, right? And I give you the code, and you use it, right? But then you want to modify that code, you generate again. And then now, after 8 steps of separation, let's say, what you got at the beginning is completely different. Is this the world we're going to have? How can we control it? And I mean, of course we can control it, but yeah. So a generated world is not so stable.
Yes.
In the context of Gen AI at its current state, would you say prompt engineering is training it to be better, or are we still leaning towards fine-tuning?
Oh, can you say it again? I don't know exactly. I don't get it from here.
Okay.
Can you
Can you hear me now? Yeah.
Yes. That's
Okay.
just a question, so I know it's.
Yeah. Well, I was saying in the context of Gen AI at its current state, would you say is prompt engineering training it to be better, or are we still leaning towards fine-tuning?
Worse, the generated item is worse, you say? Is it better or not to generate?
No, I'm saying is the
Is
the prompt engineering training the Gen AI to be better since it learns from the responses?
I didn't get it. Here is really difficult to hear. Can you repeat the question? Maybe you. Oh, okay, sorry. Here is really impossible. Maybe I'm deaf. So the scene is yours.
I wanted to ask, in the current context, is prompt engineering making the Gen AI train better, or are we still leaning towards fine-tuning for code generation?
I can understand the question as well. Function engineering versus generation. Oh, okay. Thank you. Sorry. Okay. Okay. I also taught search-based software engineering, and that's the same shift of paradigm. Better to be constructive, so to create something, or to compare with existing. And I think today we also have this statement. Now you're asking whether better to be constructive, so to create something, or generate something. I think as engineers, we should consider all. I mean, why stopping me to create something if I want to? If I think I'm better than a machine? Maybe I'm not, but why you stop me to just compare things and select the ones I want, like search-based? I search in the space, I find the best one. Why? Why not generating when I need? I mean, the image at the very beginning of this talk was generated because I was lazy. And I was lazy and I didn't want to infringe copyright. That was my motivation. I could have thrown myself, as I did for my picture, and constructively create a picture of myself or a picture of what I want to send as a message. Who stops us to do any of this? In this talk, I did everything. So my suggestion is, the more you know, and that's obvious, the more you know, the better you'll be in the future as developer, as software architecture. And if as a software architecture, you are also developer, very good. And data scientist, very good. And you know how to generate code in a high quality way, compare code, compare text. Because another important thing is that is not, you don't just generate code when you're a developer, you generate documentation. So also that has to be very good. We were told that when we do software development, there are different phases, and we need to be good at each of them, right? In order to get a very good final product. It's not that we miss one or we're not good for design, then the code is perfect. No, right? So anything. So my message is you need to be better than a machine. If this means constructiveness, it's okay. Yeah.
One more question.
I know you're tired. I killed you also. No, sorry, I was tired.
I have a more philosophical question.
Oh my gosh,
This is...
I'm not a philosopher.
No, because, you know, sometimes we keep saying prompt engineering. I have a different view on this, but I just want to see what... I don't think it's really engineering, but
What do you call it?
No, I'm saying, is it prompt really engineering? It's more like putting English in a right grammatical way. That's what I believe. But the main question that I had is, you said something about reasoning, right? About LLM's reasoning. And there are interesting research that is coming out from the NLP community that says LLMs cannot reason. We feel it is reasoning. Chain of thought is, for example, it's trying to imitate reasoning, but it's not actually reasoning. And there are some new proofs that are coming up. So I wanted to take your view on this, right? What do you think about this? From a code generation perspective, of course, not from the,
I'm a non-philosopher person. Okay. Reasoning is intended in terms of logic reasoning. So steps that the machine does in order to get the answer. And what I did is really fascinating because I was preparing for the students the exercise of generating the test acceptances. And I was wrong many times. Then I used reasoning. And I understood that the text I used for input was vague. I didn't realize it. For me, it was completely fine. But by see this, because the machine says, oh, maybe you mean this. It really says that.
Yeah, of course. Yeah.
And I realized, oh my God, I have to change the prompt. And the prompt you have seen now, the very nice with the layout of the acceptance tests, was like one day work. Just for that. Then I have a series of them. But just for that. Because thanks to the reasoning, without the reasoning, I didn't see it. Well, with the reason, so the stepwise procedure of the reasoning of the machine is not reasoning in other means, okay? For sure. It's just a step the machine takes because the instruction, the reasoning is a question and answer the machine does itself.
Yes.
In order to get to the best score.
Yes.
Okay? So in each of these steps, there is an answer. This answer is used for the next step. So I realized that the answers, the machine is also verbose, it explains the answers, right? So the explanation, it was not what I intended. That's a very nice thing that I think is useful for teachers to understand what they provide students as exercises, for example, but also for students, developers that use the answers. So it's not simply the prompt. So this helped me to write a better prompt. But I wanted to say that the prompt is an engineering discipline because there is a rigorous technique to do it that I tried to convey to you with this table with all the components and the function prompt. So it's not simply, it's a probabilistic study, a probabilistic analysis of the best answer, but it's done in iterations, not in one shot. Okay, so when you do, for example, chain of thoughts, or you instruct the machine to do it in steps. So it's an art, I agree.
Yeah, that's why I asked, right? Because art is different from engineering, right? That's the question I had from a philosophical standpoint. That's why you said art and engineering at the same time. So engineering could lead to art. Art can lead to engineering. So can we say the same, same line as what? Yeah.
You are a software engineer?
Yeah, of course.
Of course. Are you creative?
I think so.
That's your answer.
I think so.
That's your answer. What also Grace said, right, today, we don't forget our techniques, right? But neither our creativeness. Because we were instructed also to be creative, to use logic, but in a creative way, to create something new, or to compare with something else, search-based. Okay, so, yes, I mean, it's an art, but it's also an engineering discipline.
Yeah, we can have a debate after this, yeah, sure.
The answer is always, it depends. It depends is the first answer you always give the core students. The prompt design is the engineering, but the goal, why you do it, the way you interact with the machine, maybe combining different tools and so on, is your art. But also what you want from, because the input and the output is not the machine that tells you what it is. So what I was trying to say before, in our prompt for testing, we decided, we spent lots of time to understand which kind of input we need to give the machine. So how do we fill this X slot? And we decided to put the error trace, the code and the test of the previous iteration. Why error trace? Because it's failing, it's important, it's an piece of information. So our goal is to understand, and this is also related to all this generated data from the systems, which data is relevant for our tasks. And this is really a kind of an art.
Yeah, because, that makes sense. Because if you go from a computer history, we started with low-level programming language like assembly. No one writes an assembly. We are reaching a point where we are saying that maybe natural language is the way to code. And then you see source code engineering versus language engineering, right? Now it's not source code engineering that we're doing. It's
No.
language engineering.
Yes, definitely so.
So that's what I was trying to understand, because now the abstraction is raising at some point, and English is ambiguous. Source code is not that ambiguous. So I think there's a lot of interesting research direction for software engineering.
Yeah, for sure. We are here for that. Thanks.
So I sent you directions for the restaurant, 8 p.m. tonight. We are all together. Spapizer is in the chat. Since there is not any more security people, that they had to leave at 6, they were asking to, not stay in the building, just to, take our stuff and gradually move out. Okay. So see you in 1 hour and a half at the restaurant.